Yeah, hi everyone, welcome to PrepFusion. So we have been discussing about probability. In the last lecture, we studied about mutually exclusive and mutually exhaustive, and we were studying about the Venn diagrams, all these kind of concept we have studied, and also we have solved questions. Now we are going to continue our discussion. Probability only it is going on. This is the second lecture of probability. In this lecture, first we are going to study about conditional probability. Sir, what is the meaning of conditional probability? How do we define it? All those things we will study, but let's solve a question first, because with respect to the question it will be easier for us to understand. Okay, we will be able to derive the formula as well, and we will be able to understand the concept as well. So let's solve a very easy question. You already know that when you are rolling a dice, what is your sample space? Sir, when I roll a dice, I can either get 1, 2, 3 or 4 or 5 or 6. This is my sample space. What is the when you roll a dice, how many chances are there that you get an odd number? So what all odd numbers could be there? 1, 3, 5. These three chances are there that I get an odd number. And what about the prime number? So 2 is a prime number, 3 is a prime number, and 5 is a prime number. So what they are asking, first question they are asking is probability of occurrence of event A. What does that mean? That means they are asking, when you roll a dice, what is the probability that you get an odd number? When you roll a dice, what is the probability that you get an odd number? So favorable outcomes are 3, 1, 3, 5. Any of the number you can get, divided by total outcomes that are 6. So answer will be 1 by 2. Second, they are asking, what is the probability that you get a prime number? Okay, probability of occurrence of event B. When you roll a dice, what is the probability that you get a prime number? So when you roll a dice, you can either get 3 or you can either get 2, 3 or 5. That means favorable outcomes are 3 and total outcomes are 6. What will be the answer? 1 by 2. Third, what they are asking, find the probability that you get a odd number and a prime number. What they are asking, and means intersection. So odd number and a prime number. This is what they are asking. Odd and a prime number. And means intersection. AI and intersection. Right? So what will be A intersection B? So directly from here I can see that A intersection B is nothing but 3, 5. So which numbers are there which are odd as well and they are prime as well? 1 is a odd number, yes. Is it a prime number? No. 2 is a odd number? No. 3 is a odd number, yes. Is it a prime as well? Is it a prime number as well? Yes. So 3 will be included. 4 is a odd number? No. 5 is a odd number? Yes. Is it prime as well? Yes. So 5 will also be included. 6 is a odd number? No. So odd and prime, both conditions should be satisfied. So only two numbers are there, 3 and 5, which are odd as well and prime as well. So what will be the answer? 2 by 6. Answer will be 1 by 3. Now next question. That is very interesting. What they are asking? Probability of getting an odd number given that prime number has already occurred. What does that mean? That means event B has already occurred. So how I will show it? Probability of getting an odd number. Probability of getting an odd number means probability of occurrence of event A given that event B has already occurred. What this is? This could be said that probability of getting an odd number. Getting a odd number. Given that you have already got a prime number. Given that means this event has already occurred. Given that you have already got a prime number. Are you able to understand this point? This is how you will write it down. What does that mean? That means when you roll the dice, you already know that one of the prime number will occur. That means when you roll a dice, you already know that either 2 will occur, or 3 will occur, or 5 will occur. This you already know. You already know it. Either 2 will occur, or 3 will occur, or 5 will occur. Out of these three possible outcomes, how many of them are odd number? How many of them are odd number? So 2 of them are odd number. So what will be the probability? 2 by 3. So answer here the answer will be 2 by 3. Why the answer is 2 by 3? Let's read it again. Let's understand it again. Probability of getting an odd number. Sir, probability of getting an odd number. Sir, odd number could be 1, 3, 5. Sir, I have 3 possibilities. 1, 3, 5, I have 3 possibilities. No, read the question completely. Probability of getting an odd number given that a prime number has already occurred. That means when you roll a dice, you already know that prime number will come. That means either 2 will come, or 3 will come, or 5 will come. So this will become your sample space now. That either 2 will come, or 3 will come, or 5 will come. Is that clear to you? Okay. Either 2 will come, or 3 will come, or 5 will come. You already know it. Now out of these three outcomes, how many of them are odd number. You already know that prime number has occurred. Out of those prime numbers, how many of them are odd numbers? Sir, only 2 of them are odd numbers. So answer will be 2 by 3. Is that clear to you? We can build up a formula for this as well. What is the formula? Probability of A by B. So that is given by probability of A intersection B. A by B is there, no? So A intersection B divided by what is downward? In the denominator, P of B I will write down. So what is the probability of A intersection B? So probability of A intersection B was 1 by 3. Probability of A intersection B was 1 by 3. Divided by what is the probability of B? Probability of B was 1 by 2. So 1 by 3 divided by 1 by 2 will be nothing but 2 by 3. That's it. This is the answer. So this is how we can derive the formula as well. Is that clear to you? Next question we need to solve. What we need to solve? Probability of getting a prime number given that odd number has already occurred. Probability of getting a prime number. Getting a, just 1 second guys. Getting a prime number. Probability of getting a prime number. Given that, what is given? Given that you have already got a odd number. So when you roll the dice, you already know that odd number will occur. So this could be written as probability of occurrence of event B given that event A has already occurred. Okay. So when you roll the dice, you already know that odd number will occur. That means you already know that either 1 will occur or 3 will occur or 5 will occur. You already know one of these 3 guys would occur. That means your total possible outcomes are 3. Out of them, how many of them are prime number? So 2 of them are prime number, which are 3 and 5. So what will be the probability? Probability will be nothing but 2 by 3. There you go. So this is without formula, pure concept. Probability of getting a prime number given that you already know that odd number has occurred. So when you roll the dice, you thought that 1, 2, 3, 4, 5, 6 should occur. But no, they are saying that you already know that number will be odd. That means either 1 will occur or 3 will occur or 5 will occur. Out of these 3 outcomes, how many of them are odd? So out of these 3 outcomes, 2 of them are odd. Answer will be 2 by 3. If I apply the formula, I can apply the formula as well. Probability of B by A they are asking, no? So that would be equivalent to probability of A intersection B divided by probability of A. B intersection A, here you can write down B intersection A as well. Probability of B intersection A divided by what is in the denominator? A is in the denominator, so probability of A. So A intersection B and B intersection A both are the same thing. So probability of A intersection B is nothing but 1 by 3 divided by probability of A is nothing but 1 by 2, right? Probability of A is nothing but 1 by 2. What is the answer you are getting? 2 by 3. Okay, understandable? Well and good. So someone would say that, sir, we remember this formula. What formula we have got? Probability of event A divided by probability of occurrence of event A given that event B has already occurred. Sir, that is probability of occurrence of event A and event B divided by probability of occurrence of event B. Read the theory. Okay, theory is very important. What we are saying, probability of occurrence of event B given that event A has already occurred. That would be equals to probability of occurrence of event B and occurrence of event A divided by probability of occurrence of event A. This is good, but how I remember, my way of remembering is that probability of occurrence of event A and event B will be equals to, how I am saying, probability of occurrence of event A and B will be equals to probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred, or it will be equals to probability of occurrence of event B multiply with the probability of occurrence of event A given that event B has already occurred. This is more intuitive. Say yes or no. So this formula is more intuitive. Probability of occurrence of event A and event B. A and B both together should occur. Event A and B. That means you bring tea and coffee for me. That means you need to bring tea as well. You need to bring coffee as well. Both you need to bring. So that will be equals to probability of bringing tea multiply with the probability of bringing coffee such that you have already brought tea. Probability of getting tea multiply with probability of getting coffee such that you have already got tea. You have already got tea. Okay. Or you can say probability of getting coffee multiply with the probability of getting tea such that you have already got coffee. Is that understandable to you or not? So this is the way of remembering the things. Okay, I will remember this formula rather than focusing on this one. I will focus more on this one. I will focus more on this one. And from here you got to know one thing, that P of A multiplied with P of B by A equals to P of B multiplied with P of A by B. Usually people remember in this way, but we need to understand the theory, we need to understand the language. What is the language that we need to keep on speaking? So here conditional probability is written. P of A is probability of occurrence of event A, P of B is probability of occurrence of event B, P of A intersection B is probability of occurrence of event A and event B. P of A by B is probability of occurrence of event A given that B has already occurred, and P of B by A is probability of occurrence of event B given that A has already occurred. Is that clear to you or not? Absolutely, sir, completely clear. Say yes or no. And from here what you will remember? You will remember only one thing, that's the probability of occurrence of event A and probability of occurrence of event B. Probability of occurrence of event A and B. What is the theory? The theory is probability of occurrence of event A and event B will be equals to probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred, or probability of occurrence of event B multiply with the probability of occurrence of event A given that B has already occurred. This is your probability of A intersection B. From here you got to know that these two are also equal. P of A multiply with P of B by A would be equals to P of B multiply with P of A by B. This is also very important. This result is also very important. Also you need to understand the theory as well. Probability of occurrence of event A and B will be equals to probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred, or probability of occurrence of event B multiply with probability of occurrence of event A given that B has already occurred. Is that understandable to you or not? Completely, sir, absolutely understandable. Very important. Okay, from here we derive the formulas that if you see this formula, then from here what do you understand? P of B by A could be written as P of B intersection A or A intersection B divided by P of A, right? Or P of A by B could be written as probability of A intersection B divided by probability of B, right? What else? And from here one more thing you have understood, the probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred, probability of occurrence of event B multiply with the probability of occurrence of event A given that B has already occurred. Both are same. So these are the conclusion that we have made. Only one thing if you remember, no, only this line you remember, then job is done. What is the probability of occurrence of event A and B together? A and B together means first you occur event A, then you occur event B given that A has already occurred, or first you occur event B, then you occur event A given that B has already occurred. That's the way. Is that clear? Absolutely, completely clear, sir. All these slides, everything is absolutely clear. Solve this question. First of all, you will solve without formula. After that, you will solve with formula. So method 1 without formula. What this is saying? What you need to find? You need to find probability of A by B. Sir, what is the meaning of A by B? What is event A? Event A is nothing but probability of getting the sum of the number appearing on the dice is 6. That means probability of getting the sum is 6. Sum is 6. Given that, what is given? Probability such that sum is 6 given that the same number appears on both of the dice. That means the number is, both numbers are same. Both numbers are same. Both numbers are same. This is given. What does that mean? This means that they are saying that when you are rolling a dice, when you are rolling a dice, you already know that both numbers are same. What does that mean? That if I am rolling a dice, I already know that either I will get 1 1, or I will get 2 2, or I will get 3 3, or I will get 4 4, or I will get 5 5, or I will get 6 6. So this is my sample space now. What is my new sample space? This is my sample space, that if I am rolling a dice, the number on both of the dice is same. Either it is 1 1, or it is 2 2, or it is 3 3, or it is 4 4, or it is 5 5, or it is 6 6. So what are the total possible chances? I am having total possible chances of 6. Right? And what they are asking? They are asking the sum has to be 6. if you are rolling these dices and if these are your possible outcomes, I know that when I am rolling a dice, sir, my total possible outcomes are 36. But what they are saying, they already know that the same number has appeared on both of the sides. That means either 1 1 has appeared, or 2 2 has appeared, or 3 3 has appeared, or 4 4 has appeared, or 5 5 has appeared, or 6 6 has appeared. Now, out of these possible cases, which is the case where the sum is 6? Here, what is the sum? Here, the sum is 2. Here, what is the sum? Here, the sum is 4. Here, what is the sum? Here, the sum is 6. Here, what is the sum? 8. Here, the sum is 10. And here, the sum is 12. So, what is your desirable case? This is your desirable case. That means 1 by 6 is the answer. There you go. That's it. This is the answer. What we already know, what has already occurred. Sir, we already know that both of the numbers are already same. That means either 1 1 has occurred, or 2 2 has occurred, or 3 3 has occurred, or 4 4 has occurred, or 5 5 has occurred, or 6 6 has occurred. That we already know. Now, sir, what we need to find? In these 6 cases, what are the cases where your addition is 6? Where your sum is 6? Sir, only one case is there. So, answer is 1 by 6. There you go. Method 2. We will find P of A. That means when you are rolling 2 dices, then what will your sample space? So sample space will be 1 1, 1 2. In that manner, it will keep on going 6 6. So total cases would be 36. Total cases would be 36. The sum of the numbers appearing on the dice is 6. How many cases would be there? Do you remember the way? Sir, the way was sum is 1. Sum could be either 2 or 3 or 5, 4 or 5 or 6 or 7. In that manner, it will keep on going. And how many ways are there? Ways would be, sir, 1 way, 2 way, 3 way, 4 way, 5 way, 6 way, and then 5 way, and in that manner it will keep on going. So the sum is 6. How many ways are there? 5 ways are there. So 5 by 36. P of B. What will be P of B? The number appearing on both of the dice is same. So how many total ways are there? Total ways are 36. Basically, we are treating them as a separate event now. P of A means when you roll a dice, what is the meaning of P of A? When you roll 2 dices, when you roll a pair of dice together, then what is the probability that your sum is 6? So the probability will be 5 by 36. When you roll a dice, what is the probability that number appearing on both of the dice is same? So how many total cases are there? Sir, the total cases would be 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. That means total 6 cases are there. So P of B is 6 by 36. Now what will be PA intersection B? PA intersection B. What is the meaning of PA intersection B? When you are rolling 2 dices together, what is the probability that the sum is 6, and number is also same. Number same. Sum is 6 and number is same. Sum has to be 6. That means sum has to be 6. What all cases are there? Sum has to be 6 means, sir, it could be 1 5. It could be 2 4. It could be 3 3. Sir, it could be 4 2. It could be 5 1. These 6 cases are there. In these 6 cases, how many cases are there such that you get both of the numbers same? Sir, only one case. So what will be the answer? 1 by 6 or 1 by 36? 1 by 36 will be the answer. Why 1 by 36 is the answer? Sir, why not 1 by 6? Because and is given. No, and is given here. Not given that. Given that means the event has already occurred. If the question was that find the probability such that the numbers are same, given that the sum is 6, then the answer would have been 1 by 6. But now the answer is 1 by 36 because and is given. No, this given that is a separate thing, and is a separate thing. And is given. That means you need to take only that case. You need to take only that case which will have the sum equals to 6. Also, it will have the number same as well. So what is that case? So that is only one case, and that case is nothing but 3, 3. Which case you need to take? That sum has to be 6. Also, the number has to be same. So only one case is there, so that is 3, 3. So one case out of 36. You are rolling 2 dices together. You have to take that case where you get sum equals to 6 and both of the number also same. So sum equals to 6 and both of the number also same. So what is that case? 3 plus 3 and number both same means 3, 3. That means one case would be there out of 36. Now what you are supposed to find out? Now you are supposed to find out probability of A by B. What you are supposed to find out? Probability of A by B you are supposed to find out. What does that mean? Probability of what is A? Probability of getting a sum 6, given that Numbers are same. Numbers are same. So now you already know that numbers are already same. That means my desirable cases are only 6. No desirable cases. My total possible outcomes are 6 only. These 6 cases are there. That it is already given that I will get the same number. Out of those 6 cases, how many cases will have the sum equals to 6? Out of these 6 cases, only one case will have the sum equals to 6. So answer will be 1 by 6. But here we are solving with respect to formula. So what will be the answer? Sir, P of A intersection B divided by P of B. What is P of A intersection B? Sir, P of A intersection B is 1 by 36. 1 by 36 divided by 6 by 36. 6 by 36. What will be the answer? 1 by 6. Okay, so answer is 1 by 6. Understandable? If you were supposed to find out P of B by A, then what would be the answer? P of B by A. So that would be P of A intersection B divided by P of A. What is the answer you are getting? P of A intersection B is 1 by 36. 1 by 36 divided by P of A. What is P of A? P of A is 5 by 36. P of A is 5 by 36. 36 getting cancelled out. Here the answer would have been 1 by 5. Although your actual answer is of this question is 1 by 6, but here the answer would have been 1 by 5. Now what is the meaning of this? Probability of having the same number such that the sum is 6. P of B by A. What is P of B by A? What is P of B by A? Probability of getting the same number. Probability of getting the same number given that the sum on the number is 6. So what all cases are there? Sir, sum should be 6. So cases are 1 5, 5 1, 2 4, 4 2, 3 3. So total 5 cases are there. Out of those 5 cases, which case is there where the number is same? Event B probability. Then out of those 5 cases, which cases are there where the number is same on both of the dice? Where the number is same on both of the dice, only one case is there. So what would have been the answer? Answer would have been 1 by 5. Are we getting the same answer? Yes. Are you able to understand this? Are you able to understand the meaning of two things, which is and one term is and other term is given that, and given that both are separate things? Okay, eventually what you will do is that a lot of people will say that both are same, but both are not same. And given that both are not same. Okay, what is the meaning of and? Event means both of them together should occur. And what is the meaning of given that? Given that means one output you already know. That means you already know that the same number would appear. You already know that same number would appear. That means, sir, either 1 1 would appear, or 2 2, 3 3, 4 4, 5 5, 6 6. So I already know that out of those 6, one of the case would occur. Now which case you are interested in? You are interested in the case where the sum is 6. So only one case is there, 1 by 6. And similarly here, P of B by A, what does that mean? That means you already know that the sum would be 6. Sum would be 6 means, sir, it could be either 1 5, 2 4, 3 3, 5 1, 4 2. These 5 cases are there, but I am interested in which case? I am interested in that case where the sum is 6. Sorry, I am interested in that case where the number are same. So which case is there? The number are same. Only one case is there, which is 3, 3. So 1 by 5 would be the answer. Is that clear to you or not? I hope you have understood the meaning of conditional probability. Probability of occurrence of event B given that A has already occurred. Probability of occurrence of event A given that B has already occurred. Probability of occurrence of event A and event B. Okay, here it is and here it is given that. This will show and this will show given that. Basically here there is a number and here also there is a number. So this is showing given that and this is showing and. So both are separate things. Eventually people will think that both are same, but both are not same. P of A intersection B is different. P of B by A is different. P of A by B is also different. Is that understandable to you? Probability of occurrence of event A and event B. Probability of occurrence of event A given that B has already occurred. Probability of occurrence of event B given that A has already occurred. All three are separate things. I hope with these examples everything is clear to you. Say yes or no. Okay, well and good. Next question. This is completely formula based question. You need to solve with respect to formula only. P of A is given, P of B is given, P of B by A is given. You need to find out this particular thing. What we are supposed to find out? First of all, let's see what we are supposed to find out. P of A bar divided by B bar, right? So how we will solve it? P of A bar intersection B bar divided by P of B bar. Say yes or no, right? Understandable, very straightforward, right? P of A bar, what we used to do, P of X by Y. What will be the answer? P of X intersection Y divided by P of Y. So same thing we have written. In place of Y, we have put B bar. In place of X, we have put A bar. So P of A bar intersection B bar divided by P of B bar. Now A bar intersection B bar, how it could be written? A union B whole bar. Say yes or no. Divided by P of B bar. De Morgan's theorem we have applied. Okay, which theorem? De Morgan's theorem. P of A union whole bar. A union B whole bar. Right? This we have already seen. A bar intersection B bar could be written as A union B whole bar. A bar union B bar could be written as A intersection B whole bar. So this thing we have written. Now how this could be written? This is P of event E bar. That means P of event E bar could be written as 1 minus P of event E. So 1 minus A union B divided by 1 minus PB. So what you are supposed to find out? You are only supposed to find out A union B. You are only supposed to find out P of B. P of B is already given. Our target is finding P of A union B. So here we will write down the answer. But let's see. P of A is given. P of B is given. P of B by A is also given. P of B by A is also given. What does that mean? P of B intersection A divided by P of A is given, which is given as 0.5. So from here what you can see, P of B intersection A we need to find out. P of B intersection A we need to find out. Multiply with 0.5 into P of A. P of A is 0.3. That is 0.15. So P of A intersection B is 0.15. Right? So you are having P of A intersection B, you are having P of A as well, you are having P of B as well. Our target is to find out P of A union B. So can you find out P of A union B? Absolutely, sir. P of A union B will be nothing but P of A plus P of B minus P of A intersection B. What is P of A? Sir, P of A is 0.3. What is P of B? That is 0.6 minus P of A intersection B will be 0.15. So 0.9, this will become 0.75. So P of A union B is coming out to be 0.75. Job done. Here what you will write down? 1 minus 0.75 divided by 1 minus 0.6. So what is the answer? 0.25 divided by 0.40. 5 by 8 is the answer. Right? That's the answer. Completely formula based question, there is nothing. Only formula based. Just formula, nothing else. What we are supposed to find out, just we wrote down the answer that A intersection A bar intersection B bar. It could be written as A union B whole bar. It could be written as 1 minus a P of A union B divided by 1 minus PB. Right? Now we are supposed to find out A union B. So we need to hold on to that. Like this is simply just what I do. I keep it in a box, otherwise people will be getting confused. So what I thought, I need to find out A union B. So let's see what all information is already given. Information already given is P of B by A. From here I can find out P of A intersection B. If I know P of A intersection B, I know P of A as well, I know P of B as well. I can find out P of A union B. That is P of A plus P of B minus P of A intersection B. That is 0.75. Job done. That's it. Okay. Next question. P of X is given. P of X by Y is given. P of Y by X is given. You need to find out all these values. Okay. For P of Y, what you will do? So this is actually very important. A lot of times would happen that you will have these values, you need to find out P of Y. What you need to remember, I told you one thing, that probability of occurrence of event X and event Y would be equals to what? Probability of occurrence of event X multiply with the probability of occurrence of event Y given that X has already occurred. Or it would be equals to probability of occurrence of event Y multiply with probability of occurrence of event X given that Y has already occurred. So without writing this particular thing, you should be having the habit that both of them you would be able to write down in this way. Say yes or no. Will you have the habit or not? Directly, probability of occurrence of event X multiply with the probability of occurrence of event Y given that X has already occurred would be equals to probability of occurrence of event Y multiply with probability of occurrence of event X given that Y has already occurred. So P of X I already know, 1 by 3. Multiply with P of Y by X I already know, that is 2 by 5. Probability of occurrence of event Y I am supposed to find out. Probability of occurrence of event X multiply with 1 by 2. If you have the good enough habit, no, then directly you will be able to write down this line. what you will think probability of occurrence of event x multiply with the probability of occurrence of event y given that x has already occurred. 1 by 3 multiplied with 2 by 5 will be equals to probability of occurrence of event y multiply with the probability of occurrence of event x given that y has already occurred multiply with 1 by 2. There you go. Directly you will be able to write down if you are having good enough habit. So probability of occurrence of event y will be what? Probability of occurrence of event y will be nothing but 4 by 15. Do we have another page? Yes. Okay, good. So answer is 4 by 15. This 2 goes here. 4 by 15 will be the answer. This is the answer that we are getting. Okay. So first one is done. So this should be the habit. Okay. You need to build up this habit because again and again we are going to study total probability as well. We are going to study Bayes theorem as well. There we are not going to write down the formula. Okay, sir. Probability of x intersection y. Their intuition should work. Probability of occurrence of event x multiply with the probability of occurrence of event y given that x has already occurred would be equals to probability of occurrence of event y multiply with the probability of occurrence of event x given that y has already occurred. Now, if this formula is there, will you be able to think? Will you be thinking that, sir, what is the formula? No. Theory. Probability of occurrence of event x and y. Probability of occurrence of event x and event y. That would be equals to probability of occurrence of event x given that, sorry, probability of occurrence of event x multiply with the probability of occurrence of event y given that x has already occurred. This should be your way. Or probability of occurrence of event y given that and multiply with the probability of occurrence of event x given that y has already occurred. So this is how you should be able to write down 1 by 3 multiply with the y by x, that is 2 by 5. So answer will be 2 by 15, or p of y that came out to be 4 by 15 multiply with p of x by y, which is 1 by 2. So in both of the cases the answer you are getting is 2 by 15. So it's not that, sir, you will write down the total like how people would be solving it in class 12th. How we used to solve it? We used to remember this formula. Okay, sir, we need to get p of x intersection y. Sir, I know this formula. So p of x intersection y divided by p of y. Sir, I don't have the p of y value. That means I need to apply this formula now. P of x intersection y divided by p of x. Now I have the value of p of x. I have the value of p of y by x. Then this is the formula that we are getting. No, this is not how we will be solving in the engineering. In the engineering, we will learn the statement, that how we will speak this statement. What is the way of telling this statement? The way of telling this statement is probability of occurrence of event a probability of occurrence of event x and event y. That would be equal to probability of occurrence of event x multiply with the probability of occurrence of event y given that x has already occurred, or probability of occurrence of event y given that multiply with the probability of occurrence of event x given that y has already occurred. Right? First you have bring tea, then you are bringing coffee such that you have already brought tea. First you are bringing coffee, then you are bringing tea such that you have already brought coffee. Understandable? So this is how we need to speak the theory. Same goes here as well. Both are equal. So directly I got the answer. Here also directly I got the answer. Now p of x union y we need to get. Right? X union y. So probability of x union y. So everything we are having x union y. What that would be equivalent to? Probability of x plus probability of y minus probability of x intersection y. So what is probability of x? Probability of x is 1 by 3 plus probability of y is 4 by 15 minus probability of x intersection y is 2 by 15. Right? So this will become 2 by 15 and this will become 5 by 15. Right? 5 by 15, 2 by 15. Answer will be 7 by 15. That would be the answer. Okay. When you solve it, you will get 7 by 15. That's the answer. Very simple. Simple formula we have applied. P of x plus p of y minus p of x intersection y. So p of x 1 by 3, p of y is 4 by 15. Right? So that will become 9 by 15 minus 2 by 15. That's the answer. Okay. Let's go to the next one. P of x bar y. D is P of x bar y. What we will do here? So the formula would say P of x bar intersection y divided by P of y. Now, sir, I don't know what it shows. X bar intersection y. So make the Venn diagram. No, make the Venn diagram. X bar intersection y. What is x bar intersection y? This is your x. This is your y. What is x bar intersection y? X bar means everything apart from x. X bar means everything apart from x, everything apart from x. This is your x bar. Intersection with y, common with y. What is the portion which is common with y? What is the portion which is common with y? This is the portion. So this is the portion of what this is. This is your nothing but x bar intersection y. A lot of times we have seen it. X bar intersection y. Apart from x, everything common with y. Apart from x, everything common with y is this. So can I write it down as p of y minus p of x intersection y? Say yes or no. Divided by p of y. Divided by p of y. So from here I know the value of p of y as well, and from here I know the value of p of y as well. I know the value of p of x intersection y as well, and p of y value also I know. So I will get the answer. But let's see one more thing. If you divide p of y, what you will get? 1 minus p of y divided by p of y will be p of y will be 1. Basically what I am doing, this p of y is in the denominator, no? So what I am doing, p of y divided by p of y minus p of x intersection y divided by p of y. P of y divided by p of y will become 1 minus p of x intersection y divided by p of y. What is this will become? P of x by y. Did you understand this point? This will become p of x by y, no? Clear, right? This is clear, no? P of x by y. What will be p of x by y? That will be, sir, p of x intersection y divided by p of y. So what you are getting, p of x bar y, p of x bar divided by y is equals to 1 minus p of x by y. That means what you can see, p of x by y plus p of x bar y is coming out to be 1. If you can remember it, you can remember it. Otherwise, we will see these kind of concept again. Don't worry. When we study about total probability theorem, no? Total probability, when we study about Bayes theorem, at that time it will come again. But for now, you can try remembering it. Like basically, you already know that p of x plus p of x bar equals to 1. So probability of occurrence of event x plus probability of occurrence of not event x is equals to 1. So here what you will say, probability of occurrence of event x given that y has already occurred plus probability of not occurrence of event x given that y has already occurred, that will be also equals to 1. So what will be the answer here? Eventually the answer will be 1 minus p of x by y. What was the answer of x by y? That was 1 by 2. Answer will be 1 by 2 only. So what will be the answer? Answer will be 1 by 2. So if I directly see it, no, so I would be able to understand it will be nothing but 1 minus p of x by y. 1 minus p of x by y is nothing but 1 minus 1 by 2. Answer will be 1 by 2. So job done. Answer will be 1 by 2. That I will be able to mark very easily in the examination hall. But again, you don't need to remember all those things. Okay. If you are not able to remember, no need to worry about it. No need to remember all those things. Just that you need to have the process. What will be the process? That's our x bar y I need to take. That means x bar intersection y. So this will be x bar intersection y. So this could be written as p of y minus p of x intersection y. That would be 1 minus. Now I have the value of p of y. I have this value. I have this value. Put the value. Get the answer. If you are directly able to remember this thing, then you will be directly able to solve it. Otherwise, no need to remember the things. You will be able to solve in this manner. Is that question clear? That how we will solve the problem. So these two are important. That sir, without writing down the formula, we should be able to solve these two problems. P of y would be p of x multiplied with p of y by x. That would be equals to p of y multiplied with p of x by y. Okay. Similarly, p of x intersection y, that would be equals to p of x dot p of y by x equals to p of y dot p of x by y. So don't remember them as a formula. Always say the theory. What is the statement? Probability of occurrence of event x multiply with the probability of occurrence of event y given that x has already occurred. So if you remember the formula, you will be forgetting the formula. But if you have the theory in your mind, you will never ever forget the theory. Understandable? So in that manner, these two without the formula, after that you apply the formula. Understandable? Let's solve the next question. It is not the question, it is just the theory. What is the probability of occurrence of event A and event B? So can we say in this manner, probability of occurrence of event A and event B? So sir, it is written as probability of occurrence of event A multiply with probability of occurrence of event B given that A has already occurred, or probability of occurrence of event B multiply with the probability of occurrence of event A given that B has already occurred. So this, sir, we already know. Why you are writing down again? But this time, next what I am asking you, probability of occurrence of event A and B and C. This is what I am asking. What I am asking, probability of occurrence of event A and B and C. This is what I am asking. So what this will be equivalent to? So this will come out to be equivalent to, how it will come out? Proof also I will give, but let me write down the answer first. So that will be equals to probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred, multiply with the probability of occurrence of event C given that A and B has already occurred. This will be the answer. Or you can say probability of occurrence of event B multiply with the probability of occurrence of event A given that B has already occurred, multiply with the probability of occurrence of event C given that A and B has already occurred. Or what you can say, different ways are there. You can write down any way. You can say probability of occurrence of event C multiply with the probability of occurrence of event A given that C has already occurred, multiply with the probability of occurrence of event B given that A and C both has occurred. Given that A and C both has occurred. Right? Sir, how these formula came? Like, first of all, let me know, have you understood the formula? That how I am writing down the formula. Probability of occurrence of event A multiply with the probability of occurrence of event B. A has already occurred, so divided by A. Multiply with the probability of occurrence of event C. A and B both has already occurred, so A intersection B. If you solve it, let's solve this one. You will get the same thing. Or let's derive it. Let's see the derivation. How we will derive it. Derivation. So what I am doing is that probability of A intersection B intersection C. What I am doing is that I am assuming this as D. What I am assuming that this is D intersection C. What is D here? D is nothing but A intersection B. This is what I am assuming. I am assuming D as A intersection B. Okay. So what will be D intersection C? So D intersection C would be given as probability of occurrence of event D multiply with the probability of occurrence of event D given the probability of occurrence of event C given that D has already occurred. Right? Now what is D? D is nothing but A intersection B. Multiply with the probability of occurrence of event C given that D has already occurred. Is that clear? I am just replacing D now, nothing else. P of D intersection C could be written as probability of occurrence of event D multiply with the probability of occurrence of event C given that D has already occurred. Now I just open it up, nothing else. I am just opening it up, nothing else. In place of D I am putting A intersection B, in place of D I am putting A intersection B. Now what will be P of A intersection B? P of A intersection B will be nothing but probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred. And this is probability of occurrence of event C probability of occurrence of event C given that A and B has already occurred. So what this is coming out to be? This is coming out to be A intersection B intersection C. There you go. This is the answer. This is the answer. Okay. Probability of occurrence of event A and B and C, that would be equals to probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred multiply with the probability of occurrence of event C given that A and B has already occurred. There you go. Other formula also you can derive. Okay. Is that clear to you? So this habit you should be having. It's not that sir I will be thinking that sir what I should write down. Just any kind of event would be there. 7 events could be there. E1, E2, E3, E4, E7. In that manner 4 events could be there. Let's just say 4 events are there. How will you write down? E3 and E4. 4 events are there. How will you write down? You will write down probability of occurrence of event E1 multiply with the probability of occurrence of event E2 such that E1 has already occurred multiply with the probability of occurrence of E3 such that E1 and E2 has already occurred multiply with the probability of occurrence of E4 such that E1, E2 and E3 has already occurred. There you go. This is how you will write down. Okay. So this habit you need to have. Understandable? Whether there are 2 events or 3 events, this habit we need to have. Why we are writing down this theory? Because next topic we are going to understand, that is independent events. What is the meaning of independent events? So in independent events, this will be very helpful. Why it will be helpful? First, let's understand the meaning of independent events. What we need to do? First, we will solve a problem. With respect to problem, it will be easier for us to understand. Okay. Theory we will understand, but after solving a problem. Very easy question it is there. What they are saying? There is a box. In this box, you are having 3 red ball and 4 blue balls. 3 red ball and 4 blue balls. What they are saying, you are drawing a ball at random and its color is noted. Let's just say I draw a ball which comes out to be red. Let's just say I draw a ball that comes out to be red. So now I am noting its color. Now the ball is then placed back into the box before the next draw. That means I will see the color of the ball, then I will put it back. So when I put it back, what will happen? Again, I will have three red balls and 4 blue balls. 3 red balls and 4 blue balls. Are you able to understand this point? What I will do, in a box there will be 3 red ball and 4 blue ball. I will pick up one ball. Let's just say that came out to be red. So I will note its color and then I will again put it back into the box. So again I will have 3 red ball, 4 blue balls. Let's just say this time I got a blue ball. This time I got a blue ball. So what I will do, I will note its color. The color is blue. Then again I will put it back into the box. So now again in the box I will have 3 red ball and 4 blue ball. 4 blue ball. Is that clear to? Is that clear to you? This is known as drawing with replacement. Drawing with replacement. That means you are replacing the ball again. So first of all, what they are asking, probability of drawing a blue ball. First of all, you let me know that you need to find out the probability of drawing a blue ball. So in a box, there are 3 red balls and 4 blue balls. In a box, there are 3 red balls and 4 blue balls. What is the probability of drawing a blue ball? So there are total 7 balls. Out of 7 balls, 4 are blue. So what will be the answer? 4 by 7. Right? Next, what is the probability of drawing a red ball? In a box, there are total 7 balls. Out of those 7, 3 are the red balls. So what is the answer? 3 by 7. In a box, there are total 7 balls. Out of them, 3 are red. In a box, there are total 7 balls. Out of them, 4 are blue. So 4 by 7, 3 by 7. Next, the probability of drawing a red ball given that blue ball was drawn in the previous draw. What they are asking? Probability of drawing the red ball given that blue was already drawn in the previous draw. What really happened? That this was the scenario. 3 red ball was there, blue was, and 4 blue was there. Right? 3 red ball, 4 blue balls was there. Then what you got? First you got a blue ball. Here you got a blue ball. Here you got a blue ball. You got that blue ball, you saw the color, and then again you putting it back in the box. So again you put that in the box. Now you are having 3 red ball and 4 blue balls. Now from this scenario, what is the probability that you will be getting a red ball? What will be the probability? Sir, in the box as of now, how many balls are there? In the box, sir, as of now, I am having 7 balls. What was the scenario? Initially, this was the box. Okay. From this box, you picked up one ball. That ball came out to be blue. You saw the color, that is blue. You again put it back in the box. Now, blue color you have got, you have again put it back in the box. Now, in the box, how many balls are there? In the box, again, there are 3 red balls, 4 blue balls. Now, what is the probability that you will be getting a red ball? So, in the box, how many balls are there? 7. Out of them, 3 are red. Answer will be 3 by 7. There you go. Is it coming out to be equals to P of R? Yes, sir. Next, what they are asking? Probability of drawing a blue ball given that in the previous draw, you have already got a red ball. What they are saying? That in the previous draw, I have already got a red ball. That means, first this was the scenario. There was 3 red balls, 4 blue balls. Now I picked up one ball that came out to be red. I saw the color is red. I again put it back in the box. Now in the box, again I am having 3 red balls, 4 blue balls. What is the probability of drawing a blue ball? So how many total balls are there? 7. What is the probability of drawing a blue ball? Out of those 7, 4 are blue. Answer is 4 by 7. Isn't it equals to P of B only? What did you get to know here? That P of R by B is coming out to be P of R. And P of B by R is coming out to be P of B. From here, what you are understanding? You are understanding that probability of drawing a red ball given that blue ball was already drawn is equals to probability of drawing the red ball only. That means probability of drawing a red ball is not depending on probability of drawing the blue ball. Again, let me repeat. Probability of drawing the red ball is not depending on the probability of drawing the blue ball. Similarly, probability of drawing the blue ball is not depending on the probability of drawing the red ball. No matter in the previous draw whether you have drawn a blue ball or red ball, it doesn't depend. Because you are again putting up the ball back. No. Whatever the ball you got here. Let's just say you got a red ball here, you got a blue ball here. I don't care. Again, I will put that ball back into the box. Now the condition is that again I am having 3 red balls. Again I am having 4 blue balls. Now what is the probability they are asking? They are asking the probability of drawing the red ball. No matter whatever the draw was there in the previous scenario, whether it was a red ball, whether it was a blue ball, I don't care. In the previous scenario, whatever that has happened, I don't care. As of now, I am having 3 red balls, 4 blue balls. What is the probability of drawing a red ball? That will be 3 by 7. As of now, again, I am having 3 red balls, 4 blue balls. What is the probability of drawing a blue ball? That will be 4 by 7. No matter whatever the draw was there in the previous scenario. That means drawing a red ball is not depending on the drawing of blue balls, and drawing a blue ball is not depending on the drawing a red ball. Did you understand this point? That means two events A and B, two events A and B are known to be independent, are known to be independent if probability of occurrence of event B given that A has already occurred is equals to the probability of occurrence of event B only. There is no impact of A. Or probability of occurrence of event A given that B has already occurred would be equals to probability of occurrence of event A. Say yes or no. Is it clear? Like if this condition is satisfied, no. If this condition is satisfied, that means surely this condition will also be satisfied. From here, what you are understanding? What is the probability of occurrence of event A and B? So probability of occurrence of event A and B is equals to probability of occurrence of event A multiply with the probability of occurrence of event B given that A has already occurred, or it is equals to probability of occurrence of event B multiply with the probability of occurrence of event A given that B has already occurred. Now if A and B are independent, if A and B are independent, then what will happen? Probability of occurrence of B by A would be equals to PB, and probability of occurrence of A by B would not depend on B, that would be equals to PA. Right? This is the condition. So here you put P of A intersection B, what that would come out to be. So that is equals to P of A multiply with P of B by A. So probability of occurrence of event B given that A has already occurred, that would be equals to probability of occurrence of event B only. That would be equals to probability of occurrence of event B multiply with probability of occurrence of event A given that B has already occurred, that would be equals to probability of occurrence of A only. There you go. So what you will write down? If A and B are independent, no, then probability of occurrence of event A and B would be given as probability of occurrence of event A multiply with the probability of occurrence of event B. There you go. This is what you will write down. Along with that, you will remember one more thing, that probability of occurrence of event A given that B has already occurred would be equals to probability of occurrence of event A only. Also, probability of occurrence of event B given that A has already occurred would be equals to probability of occurrence of event B only. There you go. Is that clear to you or not? This is the meaning of independent events. That means occurrence of event A is not depending on B. Occurrence of event B is not depending on A. Okay, A and B are independent of each other. We do not depend on each other. Like let's assume one scenario that I'm asking you the probability of getting ahead given that you have got tail in the previous toss. You have already got a tail. Like basically what you did, first you tossed the coin. What you got? You got tail. Now in the next tossing, you will get head or tail. You don't know. So what is the probability of getting a head given that you have already got a tail? So sir, is this event depending on the previous one? Like on the previous toss you got head or tail, does that depend? In the last match we lost the toss. Right? So in this match we will win the toss or we will lose the toss. Like does that matter on the last toss? No. Right? Rohit Sharma lost the toss 21 times, I guess. Consecutively, 21 times. So does that depend on the previous toss? No, it doesn't depend on the previous toss. No. Today I will win the toss or lose the toss. Will it depend on the previous tosses? No. So today I will be getting head or tail. Will it depend on the previous toss that I got a tail or I got a head? It will not depend. So are they independent event? Yes, they are independent. They are independent of each other. Okay, so I hope you would have understood the meaning of independent events. Again and again we will study these concepts. It will be more clear to you. Don't worry. Okay, because they will be coming again and again. So it will be more clear to you. Don't worry about it. Let's go to our next question. Okay, so here also it will become more clear. 3, again the same scenario that you are having 3 red balls and 4 blue balls, right? You are drawing a ball at random and its color is noted. The ball is not placed back into the box before the next draw. This time you are drawing without the replacement. What does that mean? You got a ball, let's just say you got a ball and that ball came out to be red. That ball came out to be red. But now you are not placing this ball back into the box. If you are not placing this ball back into the box, that means you have already taken a red ball outside. That means now in the box you are having 2 red balls and 4 blue balls. Say yes or no. Is that clear to you? So this is what you are doing. So let's first find out the probability of drawing a blue ball. Sir, from this box, probability of drawing a blue ball will be nothing but 4 by 7. Next they are asking probability of drawing the red ball. So from this box, probability of drawing the red ball will be nothing but 3 by 7. Next, what question they are asking? Probability of drawing a red ball given that blue ball was drawn in the previous draw. Probability of drawing a red ball given that blue was already drawn in the previous draw. That means when you are drawing the ball, it came out to be blue. It came out to be blue. It came out to be blue. Now, it came out to be blue. You are not placing it back into the box. That means now in the box, what you will be left with? Blue ball you are not placing back. That means in the box now you are having 3 red balls and 1 blue ball is gone. So you are having 3 blue balls. Now what is the probability that from this box you get a red ball? So that would be 3 by 6. Because here you are having total 6 balls. Out of them 3 are red. So answer will be 3 by 6. Or you can say it is 1 by 2. Next question. Probability of drawing a blue ball given that red ball was drawn in the previous draw. Probability of drawing a blue ball given that red ball was drawn in the previous draw. What does that mean? In the previous draw, red ball was drawn. Here, red ball was drawn. So red ball is drawn, you are not placing it back into the box. That means in the box now, 2 red balls are there and 4 blue balls are there. So total 6 balls are there. Out of them, 2 are red. What is the probability? That is 1 by 3. Okay, sorry. You need to find out probability of drawing a blue ball. So total 6 balls are there. Total 6 balls are there. Out of them 4 are blue. So what is the probability? That is 2 by 3. Is it equals to the probability of drawing a red ball? Absolutely not. Is it equals to the probability of drawing a blue ball? Absolutely not. What does that mean? They are dependent events. What they are? They are dependent events. Okay. And in the previous case, they were independent events. They were independent events. So here it is depending because whatever the ball that you are drawing, that is not put back into the box, right? Understandable? We could ask one more question. The question is the probability of drawing a red ball. Probability of drawing a red ball given that in the previous draw, red ball was drawn. Given that in the previous draw, red ball was drawn. What does that mean? That means, sir, first red ball was drawn. So if red ball is drawn, then what I am left with? 2 red, 4 blue balls. Now, what is the probability of drawing a red ball now? So there are total 6 balls. Out of them, 2 are red. So answer will be 1 by 3. Is it equivalent to drawing the red ball? Is it equivalent to P of R? Absolutely not. Right? Is that clear? That means it is a dependent event. Both events are depending on each other. Is that clear to you or not? Absolutely clear. Okay. So if two events are independent, then we can write down P of A by B would be equals to P of A. P of B by A would be equals to P of B. Along with that, P of A intersection B would be equals to probability of occurrence of event A multiply with the probability of occurrence of event B, given that A has already occurred, but occurrence of event B is not depending on A. That's why I can write down in this way. So if two events are independent, then these outcomes we can write down. Next question is this. If A and B are independent events, then which of the following statements are true? If A and B are independent, then A bar and B will be also independent, A bar and B bar will also be independent, and A and B bar will also be independent. All of them are true. We can prove any one of them. Okay, I will prove only any one of them. Rest everything you will prove on your own. So what is given? What is given? Given that A and B are independent. A and B are independent. Independent. What does that mean? That means probability of occurrence of event A and B will be equals to probability of occurrence of event A multiply with the probability of occurrence of event B. Given that A has already occurred, but since they are independent, so probability of occurrence of event A multiply with the probability of occurrence of event B. This is given. This is given. What we need to comment on? First one, option A. What we need to comment on? Comment on probability of occurrence of event A bar and B. This we need to comment on. If this comes out to be, if this comes out to be in this way, probability of occurrence of event A bar multiply with the probability of occurrence of event B, given that A bar has already occurred, if this comes out to be in this way, then I will say that they are independent. Then I will be able to say that A bar and B independent. Say yes or no. This is what we need to prove. So we need to comment on A bar intersection B. Make the Venn diagram. What is A bar intersection B? 10 times we have drawn what is A bar intersection B. I guess you should be able to tell directly this time. What is A bar intersection B? Everything apart from A common with B. Everything apart from A common with B will be this one. This is your A bar B. Say yes or no. This is your A bar B. A bar intersection with B. So probability of A bar intersection B could be written as probability of B minus probability of A intersection B. Say yes or no. Probability of B minus probability of A intersection B. Probability of B. Now you already know what this is equivalent to. Probability of A intersection B. Probability of A intersection B, this is already given. That is equals to PA dot PB because they are independent events. PA dot PB. What I can do? I can take PB common. What I will get? 1 minus PA. Now 1 minus PA could be written as PB dot PA bar. There you go. That means probability of A bar intersection B. Probability of A bar intersection B could be written as probability of B multiply with the probability of A bar. Is this proven? Yes sir, it is proven. What does that mean? That means A bar and B independent. Okay, A bar and B are independent. Similarly prove other. Similarly prove that if P of A intersection B equals to P of A multiply with P of B, then what? Then P of A intersection B bar would be equals to P of A dot PB bar. P of A bar intersection B bar would be equals to P of A bar dot P of B bar, and P of A bar intersection B would be equals to P of A bar dot P of B. Is that clear to you? So if this is given, then this will be the scenario. If this is given, then this will be the scenario. And what is the theory? The theory is that if A and B are independent, then A bar and B will be independent, A bar and B bar will be independent, and A and B bar will also be independent. Is that clear to you? Say yes or no. Understandable? Okay. Let's go to the next one. This question. If A and B are independent events, then surely they will be mutually exclusive. Is this statement correct? What is given? Given is that A and B are independent. A and B are independent events. What is given? A and B are independent. That means P of A intersection B equals to P of A multiply with P of B. That is not equals to 0. That means this statement is true. This statement is wrong. What is the meaning of mutually exclusive? Mutually exclusive. What is the meaning of mutually exclusive? Mutually exclusive means mutually exclusive. C for cricketing skills. You don't want to share your cricketing skills. That means there should not be anything common. So P of A intersection B should be equals to 0. And what is the meaning of independent? Meaning of independent means probability of occurrence of event A and event B would be equals to probability of occurrence of event A multiply with the probability of occurrence of event B, given that A has already occurred. It is independent, that's why P of A dot P of B. So this is the meaning, no? So how they are connected with each other? They are not connected. People think that exclusive events and independent events are same. They are not same. They are not even connected with each other. No connection is there. No connection is there. No connection. No connection at all. Okay. Right? If A and B are independent, then surely they will be mutually exclusive. No. If they are independent, then this is the condition. It is not equal to 0. If A and B are mutually exclusive, then they will be surely independent. No. Right? What is given? Given that if A and B are mutually exclusive, that means this is given. Is this equals to P of A multiply with P of B? Absolutely not. If A and B are mutually exclusive, then P of A by B would be equals to P of B by A would be equals to 0. Yes, that is true. Why is that so? Because what is P of A by B? So that is nothing but P of A intersection B divided by P of B. Right? And what is P of B by A? P of B by A. What is P of B by A? So P of B by A will be nothing but P of B intersection A divided by P of A. Now if A and B are mutually exclusive, that means P of A intersection B would be equal to 0. What does that mean? That means P of A by B would also come out to be 0 and P of B by A will also come out to be 0 only. That means yes, this is true. If A and B are mutually exclusive events, then P of A union B will be equal to P of A plus P of B. Yes, that is also true. Let me add a page. Mutually exclusive. What is the meaning of mutually exclusive? They are mutually exclusive. So D. Mutually exclusive means P of A intersection B is 0. Exclusive means there is nothing common. This is given. So P of A union B. What will be P of A union B? So that would be probability of occurrence of event A plus probability of occurrence of event B minus probability of occurrence of event A and B. This is 0 only. So what is the answer you are getting? P of A plus P of B. Okay. So this is known as addition theorem and this is known as multiplication theorem. This we have already seen. No, if A and B are independent, then probability of occurrence of event A multiply with the probability of occurrence of event A and B would be equal to probability of occurrence of event A multiply with the probability of occurrence of event B. This we have already seen. So this is known as addition theorem. This is known as multiplication theorem, but we will not remember it as a theorem. We will simply remember one thing, that probability of A union B could be written as probability of A plus probability of B minus probability of A intersection B, which is 0 if they are mutually exclusive. And probability of A intersection B could be written as probability of A multiplied with probability of B. So what we have understood? We have understood two things, that if A and B are mutually exclusive, A and B are mutually exclusive, then probability of A union B, what this could be written as? Probability of occurrence of either A or B. That would be equal to probability of occurrence of event A or probability of occurrence of event B. So this addition is giving us a feel of OR. Right? This addition is giving us a feel of OR. Say yes or no. So probability of A or B. Sometimes I will write down probability of occurrence of event A, or I will say probability of occurrence of event A or probability of occurrence of event B. So when I say OR, sometimes I can use the addition sign. Where I will be using the addition sign? Where A and B are mutually exclusive. Is that understandable to you or not? So sometimes I will use the word OR, but I will use the additional sign. Will you be able to understand why I am using the addition sign? Absolutely, sir. I will be able to understand. Next. If A and B are independent. If A and B are independent. Dependent. Writing तो खराब ही आ रही है भाई आज. Then probability of A intersection B would be equals to probability of A intersection B. What is the meaning of A intersection B? A intersection B means A and B. That would be equals to probability of A multiply with the probability of B. So this multiplication is giving us a field of and. What kind of field it is giving? It is giving us a field of and. So sometimes I will be saying that probability of occurrence of event A and event B. I will be doing probability of occurrence of event A and event B. So when I am using and, I will use the multiplication. Okay. And if I am directly writing P of A multiply with P of B, that means they are A and B are independent of each other. Okay. So with the practice, you will be able to understand what I am saying. But always remember that union is giving us a field of OR. Union is giving us a field of OR. And that means addition. And intersection is giving us a field of AND. Means multiplication. They are equivalent? No. They are giving us a field? Yes. Are they equivalent? No, because there is a specific condition, no, that A union B would be equal to P of A plus P of B only when A and B are mutually exclusive. And P of A intersection B would be equal to P of A multiplied with P of B only when they are independent. Actual formula is P of A plus P of B minus P of A intersection B. Actual formula is P of A multiplied with P of B by A. That is the actual formula. But there is a condition here that A and B are independent. Here is the condition A and B are mutually exclusive. So with respect to this condition, we are getting these formula. But do you understand the feeling that if I say A or B, sometimes I can use the addition sign directly. There I will be using the addition sign. Why is that so? Because A and B are mutually exclusive. And sometimes if I am using the multiplication sign directly, where I will be using it? I will be using it only at that place where A and B are independent of each other. Is that understandable to you or not? Okay. So with practice, you will be able to understand what I am saying. But as of now, you just remember this thing, that this is the feeling that we are getting from here. Understandable? So this question was very straightforward. It's just that I wanted to let you know that there is no relation between independent events and mutually exclusive events. Just we know all these conditions. If A and B are mutually exclusive, then probability of occurrence of event A given that B has already occurred, or probability of occurrence of event B given that A has already occurred, would be equal to 0. This will be impossible event. And then if A and B are mutually exclusive, then probability of occurrence of event A or event B would be equal to probability of occurrence of event A plus probability of occurrence of event B. And if they are independent, then directly P of A dot P of B. Understandable? If A and B are independent events, then what will happen? If A and B are independent events, so first of all, I already know that. First of all, what do I know? Let's keep it a bit downward. First of all, I know that probability of occurrence of event A and event B would be equal to probability of occurrence of event A multiplied with the probability of occurrence of event B given that A has already occurred, and probability of occurrence of event B multiplied with the probability of occurrence of event A given that B has already occurred. Now if A and B are independent, then probability of occurrence of event A and B would be equal to probability of occurrence of event A multiplied with the probability of occurrence of event B. Say yes or no, right? Similarly, what will happen if I say A and B are, let's keep these also downward. Why is that so? Because one thing I already know. What do I know? That probability of occurrence of event A and event B and event C is equivalent to probability of occurrence of event A multiplied with the probability of occurrence of event B given that A has already occurred multiplied with the probability of occurrence of event C given that A and B has already occurred. Right? So if I say A and B, A, B, C are independent of each other. A, B, C are independent of each other. Then what will be the probability of occurrence of event A and B and C? That would be equal to probability of occurrence of event A multiplied with the probability of occurrence of event B given that A has already occurred. B is not depending on A. B is not depending on A. B and A are independent of each other. So probability of occurrence of event B given that A has already occurred. Probability of occurrence of event B given that A has already occurred would be equal to probability of B only, no? Multiply with probability of occurrence of event C given that A and B has already occurred. C is not depending on A and B. That means probability of occurrence of event C given that A and B has already occurred would be equal to probability of occurrence of C only. So they will not depend on each other. So yes, so this will be the scenario. Similarly, if there are n events, they are independent of each other. So probability of occurrence of event E1 multiply with the probability of occurrence of event E2 multiply with the probability of occurrence of E3 and En. That would be equal to probability of occurrence of event E1 probability of occurrence of event E2 given that E1 has already occurred, not depending on E1, multiply with the probability of occurrence of event E3 given that E2 E1 has already occurred, not depending, multiply with the probability of occurrence of event En given that E1 E2 E3 E4 E5 has already occurred, not depending on each other. That means simply the multiplication. So that's why I said that intersection will give us a field of multiplication. Intersection is giving us a field of multiplication. And here, what field it is giving? And probability of occurrence of event E1 and E2 and E3 and E4 and En. Right? So which is giving us a field of multiplication. Why it is giving us a field of multiplication? Is that more clear to you? Probability of occurrence of event E1 and E2 and E3 and E4 and E5, that would be equal to probability of occurrence of event E1 multiply with the probability of occurrence of event E2 multiply with the probability of occurrence of event E3, because they are not depending on each other. B is not depending on A. B will say that whether you come or not, I will be same only. C will say that whether AB comes or not, I will be same only. So they are not depending on each other. Is that clear to you or not? Okay, so in the statement you should be able to tell the probability of occurrence of event A and B would be equal to probability of occurrence of event A multiply with the probability of occurrence of event B. Probability of occurrence of event A, B, C would be equal to probability of occurrence of event A multiply with the probability of occurrence of event B multiply with the probability of occurrence of C. Understandable? Let's solve this question. Very good question. Use your brain and solve it. Two dices are thrown. Event E1 is defined as dice A shows 4. That means what is E1? E1 is nothing but 4. And E2 is defined as, okay, sorry. Two dices are thrown. No, sorry guys. Sorry. Two dices are thrown. So what is your sample space? Your sample space is 1, 1, 1, 2. In that manner it will keep on going 1, 6. And in that manner it will keep on going. It would be 6, 1, 6, 2 until 6, 6. So what is E1? E1 is saying that dice A shows 4. That means first dice is showing 4. First dice is showing 4. They are not talking about the second dice. That means second dice could be 1 as well. Second dice could be 2 as well. Second dice could be 3 as well. Second dice could be 4 as well. Second dice could be 5 as well. And second dice could be 6 as well. This is what they are saying. This is your E1. That first dice is showing 4. Okay, this is first dice and this is second dice. So first dice is showing 4. Second dice could be anything. What about event B? What about event E2? Event E2 is saying that dice B shows 2. That means second dice should show 2. First dice could be anything. That means first dice could be 1. Second dice has to be 2. First dice could be 1. Second dice has to be 2. First dice could be 3. Second dice has to be 2. First dice could be 4. Second dice has to be 2. First dice could be 5. Second dice has to be 2. First dice could be 6. Second dice has to be 2. Right? E3, the sum of the number appearing on two dice is odd. The number has to be odd. The sum has to be odd. E3. The sum has to be odd. How you can get an odd number? If you get even plus even. If you add even plus even. What number you will get? Even number only. 2 plus 4 is 6. That is an even number. If you add even plus odd. What you will get? Even plus odd. 2 plus 3, you will get an odd number. And if you add odd plus odd, what you will get? Odd plus odd. 3 plus 3 or 3 plus 5, you will get an even number. That means here what should be the scenario? That first number has to be even and second number has to be odd, or first number has to be odd and second number is even. These will be the scenarios. Say yes or no. Say yes or no. First number is even, second number is odd, or first number is odd, second number is even. In E3, these numbers will come. Let's just say 2, 3. Yes, 5. Or let's just say 3, 4, 7. Are you able to understand this point? In E3, a lot of cases would come. I am not writing down all the cases. Total 18 cases will come. If you have the concept of PNC clear, then you would know that 18 cases will come. Because how many cases will be here? 3 cases will be here. And how many cases will be here? Here also 3 cases. So 3 into 3, 9 cases are possible. And here how many cases are possible? Odd numbers could be 3. That would be 1, 3, 5. 3 odd numbers are possible. And how many even numbers are possible? 2, 4, 6. So here also 3 cases. 3 into 3, 9. So here 9 cases, here 9 cases, total 18 cases are possible. Although we don't need to write down how many cases are possible, but still, did you understand the point? That what kind of numbers would come? Here 2 numbers would be coming. First would be even, second has to be odd. Or first is odd, second has to be even. Understandable? Now what they are asking, they are talking about E1, E2, E3, E1, E2, E3. This is a JEE advanced problem. Okay, this has been asked in JEE. Either it in JEE mains or JEE advanced, I don't remember, but it is a JEE examination problem. So first what they are asking, independent events, they are independent or not. So let's comment. Probability of event even. That means when you are rolling a dice that find the probability that dice A shows 4. What will be the answer? So on dice A it has to be 4. On dice B it could be anything. So total 6 cases are there. So answer would be 6 by 36. Answer would be 1 by 6. This is your P of E1. What will be your P of E2? Probability of receiving dice B showing 2. Dice B should show 2. On dice A there could be any number. That means again total 6 cases are there. 6 by 36. Answer is 1 by 6. Next, probability of E3. I told you there will be total 18 cases. Okay. In the next lecture, I am asking you to study PNC actually. What you will do is that once you are done with this question, you will pause this video and you will study PNC. If your school level PNC is fine, then it is okay. But if your PNC is not fine, you need to study this lecture. 5-hour lecture is there. In this lecture, I have completed PNC. That will be helpful for your aptitude as well. It will be helpful for your probability as well. So you need to study PNC. But if your PNC is fine, you would know one thing, that sir, this kind of case are acceptable, that this could be even number, this could be odd number, this could be odd number, this is even number. When I'm rolling a dice, either I can get 1, 2, 3, 4, 5, 6. That means I can get 3 odd number. I can get 3 odd number. That means here there are 3 chances. Or I can get a 3 even number. That means here also there are 3 chances. Similarly here as well, 3 into 3. So total chances will be, sir, 18. So answer will be 18 by 36. That will be 1 by 2. So we have got a probability of E3, that is 1 by 2. Next, what they are asking, even and E2 are independent events or not. So that they are asking. That means let's calculate probability of E1 intersection E2. What that would be equals to. So how will I write it down? It is equals to probability of dice A showing 4. Dice A showing 4. Intersection means and dice B shows 2. Dice A shows 4 and dice B shows 2. What case will be there? Only one case would be there. So that would be dice A shows 4, dice B shows 2. That's it. Only one case is there. One case out of 36. What even intersection A2 is showing? Even intersection A2 is showing that you are rolling 2 dices A and B. Find the probability such that I get 4 on the dice A and I get 2 on the dice B. 4 on the dice A and 2 on the dice B. Intersection means and. 4 on the dice A and 2 on the dice B. Right? So on the first dice you need to get 4. On the second dice you need to get 2. So only one case is there out of total 36 cases because you are rolling 2 dices together. So one case out of 36. So answer is 1 by 36. Right? So probability of E1 intersection E2 is coming out to be 1 by 36. Is that equivalent to, just 1 second, yaar. Is that equivalent to probability of E1 multiply with the probability of E2? Absolutely, sir. What is probability of E1? That is 1 by 6. What is probability of E2? That is also 1 by 6. So what is the answer? 1 by 36. That means yes, they are equal. They are equal. What does that mean? E1 and E2 are independent. E1 and E2 are independent events. First statement is correct. What about E2 and E3? What about E2 and E3? E2 intersection E3. What about E2 and E3? So what this will show? E2 shows dice B shows 2. Dice B shows 2. And sum should be odd. Sum is odd. Sum is odd. This is what they are saying. So what all cases would be there? The case is that this should be 2, which is an even number. That means it has to be an odd number, no? What they are saying, you are rolling two dices together, A and B. Find the probability such that dice B is showing 2. Dice B is showing 2. And the addition on both of the dice, addition on A and B, that should be addition of A plus B, that should be an odd number. So if this is 2, then it has to be 1 only, no? Then you will get an odd number. Or if this is 2, then it has to be 3 only, no? Then only you will get an odd number. If this is 2, then this has to be 5 only, no? Then only you will get an odd number. Isn't it your favorable outcome? That this is fixed, this is fixed, this is fixed. So on the first dice, you can get only the odd numbers. Only the odd numbers. Only the odd numbers. So there are total 3 cases out of 36. 3 cases out of 36. Now probability of E2 intersection E3. Is it coming out to be equals to probability of E2 multiplied with E3? What is probability of E2? That is 1 by 6. Multiply with 1 by 2. Here if you solve it, this comes out to be 1 by 12. So 1 by 6. Probability of E2 is 1 by 6. What is probability of E3? That is 1 by 2. That is 1 by 12 only. So are they coming same? Absolutely, sir. They are coming same only. What does that mean? What does that mean? That simply means that they are also independent of each other. They are also independent of each other. Now I'm asking you one question, that if E1 and E2 are independent and E2 and E3 are independent, then surely E1 and E3 will be independent. Is that correct? What question I'm asking you? Look, I will remove this thing, okay? Important prerequisite before the next video, not next video, next part actually, because after that we are going to solve problems only. So you need to study PNC. Okay, so simply go to YouTube and type PNC for gate, you will get this video. So forget about this particular scenario. I am erasing it. Now I am asking you one question. What question I am asking you? That it is given that E1 and E2 are independent. We have talked about E1, E2, no? E1, E2, E2, E3 we have talked about. E1 and E2 are independent. This is given. P of E1 multiply with P of E2. Also, E2 and E3 are also independent. E2 and E3 are also independent. From here, can you conclude, can you say anything about E1, E3? You cannot say anything about E1, E3. From this particular statement, what you can understand? You can understand only one thing, that sir, P of E2 by E1 equals to P of E2. P of E1 by E2 equals to P of E1. Right? Along with that, you can say P of E3 by E2 equals to P of E3, and P of E2 by E3 equals to P of E2. Can you comment anything on even E3? Even E3 together? No, you cannot comment. No comments could be made. How you can say that it will be equals to P of E1 dot P of E3? You cannot comment. Or can you comment? Even E3. No, we cannot comment. No. So no comments could be made. No comments could be made. No comments here. Is that clear to you? Will they be dependent or independent? You cannot make any comment. Clear? So let's solve the C option. We need to comment on even E3. They may be dependent, they may be independent. I don't know. They may be dependent or independent. I don't know. Or independent. I cannot comment. I will have to check. So let's check now. What will be the probability of E1 and E3? That means what they are asking. Probability of occurrence of E1 and E3. E1 and E3. That means dice A showing 4 and the sum is odd. Dice A showing 4 dice A shows 4 and sum is odd. This is what they are asking. That means dice A will show 4. Sum has to be odd. That means this number has to be 1. Dice A shows 4. Sum has to be odd. That means this number has to be 3. Dice A shows 4. This number has to be 5. Is that clear to you? This is fixed. No, this is fixed. This is fixed. The dice A has to show 4 only. But the sum has to be odd. Sum has to be odd. That means this number could be either 1 or 3 or 5. If it is 2, then what will happen? 4 plus 2 is even. If it is 4, then what will happen? 4 plus 4 is even. If it is 6, then what will happen? 4 plus 6 is even. That means 4, 1, 4, 3, 4, 5, only 3 are acceptable. Out of total 36 cases. 1 by 12. Right? Notice that it is written and, not given that. Given that is a separate case and is a separate case. If it was written that dice A shows 4, given that sum is odd. Given that sum is odd. So you need to write down all those cases where sum is odd, and then you need to see in which cases we have got 4. Let's just say the question was dice A shows 4. Dice A shows 4 given that sum is odd. Sum is odd. So you know that sum is odd, there will be total 18 cases. Out of those 18 cases, how many cases will be there where dice A will show 4? That means dice A will show 4 and sum has to be odd. So there will be total 3 cases. So answer would have been 3 by 18 or 1 by 6. This would be the answer. And you can check by the formula as well. Probability of E1 by E3 I am asking, So that will be even intersection E3, that is 1 by 12 divided by probability of E3. What is the probability of E3? That is 1 by 2. So what you are getting? 2 by 12, answer is 1 by 6 only. So given that and both are separate thing. Given that and both are separate thing. Again and again I am telling. Because in the longer time what people will do is that they will treat them as same. And means total 36 cases are there. Your sample space is same. Whichever the first sample space is there, rolling 2 dices, that sample space is same, 36. But now both the condition you need to satisfy. That means dice A showing 4 and the addition should be odd. That means this is already an even number. This is already an even number. Next number you need to have odd number. That means 135. So total 3 cases are there out of 36. Answer is 1 by 12. And if it was given that sum is odd, that means you need to take all those cases where sum is odd. So total 18 cases are there. Total 18 cases are there. Now out of those 18 cases, which cases are there in that first dice is showing 4? How many cases are there such that first dice will show 4 and the sum has to be odd? Sum has to be odd. That means here it could be 1, here it would be 3, here it would be 5. So total 3 cases are there out of 18. So answer would be 1 by 6 there. Okay. So both are the separate things. Again and again I am telling the same thing for you, that both are separate things. Both are separate things. That means yes, sir. And from here what you understood? You understood one thing, that probability of E1 intersection E3 is actually coming out to be equals to probability of E1 multiply with probability of E3. You can check what is the probability of E1. Probability of E1 is 1 by 6. Probability of E3 is 1 by 2. So 1 by 6 multiply with 1 by 2 is nothing but 1 by 12. It is coming out to be same only. Okay. What does that mean? That means they are independent. D. E1, E2, E3 will be also independent. Is that correct? Let's check. E1 intersection E2 intersection E3. What does that mean? What is E1? Dice A show 4. And what is E2? Dice B show 2. Right? What is E2? E2 is dice B showing 2. Dice B shows 2. And what is E3? E3 is sum is odd. Sum is odd. What will be the probability? They are saying that first dice should be 4, second dice should be 2, and the sum has to be odd. What is the sum? Sum is 6. There is no cases like that. What will be the answer? 0. Is that clear to you? Think about it. No, you are rolling 2 dices together. Dice A should show 4, dice B should show 2, and the sum has to be odd. Is it possible? 4 plus 2 is 6. It is not even possible. What is the probability? 0. So is it equivalent to probability of E1 multiply with probability of E2 multiply with probability of E3? No, sir. probability of E1 multiplied with E2 multiplied with E3 is 1 by 6, 1 by 6, 1 by 2. That will be 1 by 72. That is not equivalent to 0. That means they are not independent. They are mutually exclusive because their intersection is coming out to be, probability of their intersection is coming out to be 0. That means they are mutually exclusive. Mutually exclusive. Is that understandable to you? So this is how we will check. Have patience, use your brain, write down probability of E1, probability of E2, probability of E3, write down all the cases and solve these kind of problems. Very good question. These kind of questions can solely be asked in your GATE examination as well. Okay. Is that clear to you? So already we have spent roughly around 100 minutes on this lecture. Next we will solve problems only. So I need to take a break and I will change the slides because slide has been completed here. Okay, 50 slides have been completed here. So I need to change the slide. I will take a break and now we are going to solve problems only. But important part is P and C. P and C is very important. P and C is very, very, very important. You need to have a good idea of P and C. Then only you will be able to solve those problems. So if you have studied P and C, it is good. If you have not studied it, study P and C and then again come back here. So P and C is very important. Okay. Again, I cannot teach the full concept of P and C, but I will try to use minimum of P and C because in probability what happens is that people try to use a lot of P and C and in that they mess it up. If you use too much of P and C, no, then you mess up the questions of probability. So next we are going to solve a lot of problems. There I will tell you that using minimum P and C, how you can solve these kind of questions. So that will be my, that will be my target, that I teach you probability using the minimum concept of P and C. But some concepts should be clear. Okay, like if there are 10 guys and let's just say I'm having 10 letters. So using those 10 letters, how many words I can make? 10 factorial, right? And if there are repeated letters, let's just say I need A, B, C, D. Using these letters, I need to frame words. How many words I will be able to frame? Sir, there are total 7 letters. Sorry, there are total 6 letters. So 6 factorial. Is this the answer? No. If they were different, no, A1, A2, A3. If they were different, then this would have been the answer. But if they are same, the answer would be 6 factorial divided by 3 are same, no? 3 factorial. That's it. Only this much concept you require. Nothing else. Only this much concept you require. Nothing else you require. If you know this concept, job done. Okay. Let me ask you one more problem. That if I am having a word, let's just say Mississippi. That word is there, no? Mississippi. I don't remember the spelling. Forget about it. Let's take some other words. Let's just say I am having a word B, C, D, D, A, F. So using these letters, how many words I will be able to frame? So how many total letters are there, sir? 3 plus 3, 6, 8. 8 factorial. Is this the answer? This would have been the answer if they were different. D1, D2, A1, A2, A3. If they were different. But since they are same. So who are same? Sir, 2D are same and 3A are same. So this would be the answer. Total these many words would be possible. Is that clear? So if you know this concept, then you will be able to understand P and C. So sorry, you will be able to understand probability. Okay. So next we are going to solve the problems only. But before studying those problems, if your concepts of P and C are good enough, whatever the prerequisite I gave here, no, if you know this much, then job is done. Okay. So let's start with the questions. But I need to take a break and then I will come back and we will solve the problems. Okay. Yeah, welcome back. So now we need to solve the problems. Okay. So a lot of questions are there in this lecture. We will try to solve as many problems as we can. At least we will try to take 15 problems. Okay. In this lecture, at least 15 questions we will try to take. Secondly, we are not giving any topic to any question. Let's just say this particular question is based on this particular topic. This question is based on conditional probability. This question is based on cards. So these kind of topics I am not giving. Why is that so? Because in the examination topic will not be given. No. The thing with probability is that if you know that sir, this topic is from total probability. If this question is from Bayes theorem. If this question is from conditional probability, then you would be able to solve the problem. But if the question is coming directly without mentioning the topic, then you will be struggling, no? Right? So that's why we are not giving any topic. We will directly solve the problem. So let's try solving the question. What is given? 4 identical apples are there. You are having 4 identical apples. 4 identical apples. And 3 identical oranges. 3 identical oranges. 4 identical apple and 3 identical oranges are there. You are randomly arranging them in straight line. So how many total ways are there? Total ways of arranging these guys. So total 7 guys are there. So total ways would be 7 factorial. But these 4 guys are same. 7 factorial divided by 4 factorial. These 3 guys are same divided by 3 factorial. So this is the total ways. This is the total ways of arranging total ways of arranging 4 identical apples and 3 identical oranges. This is the total way. Okay, now what is your desired way? Desired way is that find the probability that fruits are placed in a manner that two extreme ends are both oranges. That means you need to place 7 guys, 3, 4, 5, 6, 7. 7 guys you need to place, but these guys has to be orange. They are fixed. They have to be orange. Now in between, what you can keep? You need to keep 4 apples. You need to keep 4 apples and 1 orange. This is what you need to do. They are fixed. This is fixed. Both of them are fixed. This is also fixed. This is also fixed. Now you need to arrange these guys. Now is it necessary that all 4 apple comes together? No. Is it necessary that orange should come in last? No. Right? So 5 guys I need to arrange. How many ways would be there? Sir, 5 factorial. But 5 factorial would have been the answer if they were different. If they were different. But they are same. That's why 5 factorial divided by 4 factorial. Is that clear to you? Okay. So what will be your probability? Your probability will be nothing but 5 factorial divided by 4 factorial. So what will be 5 factorial divided by 4 factorial? 5 factorial divided by 4 factorial will be 5 only. And what this would be? 7 into 6 into 5. This will be 35. This will be 35. Okay. You can solve this. 7 factorial divided by 4 factorial. So 7 into 6 into 5 into 4 factorial divided by 4 factorial into 3 factorial is 6. So 4 factorial getting cancelled out. 6 and 6 getting cancelled out. 7 into 5 is 35. So this is 35. So total outcome, total possible outcomes are 35. Out of them, desirable are 5. So 5 by 35, answer is 1 by 7. That's it. So this is the probability. Very simple question, very straightforward. These kind of question will be solved if you know the basic concept of P and C. So only you need to know the basic concept of P and C, and these kind of questions will be solved. So answer is 1 by 7. Okay, job done. Let's go to the next one. A leap year is selected at random. These are very famous kind of question. What do you mean by leap year? What do you mean by leap year? Leap year means it will have 366 days. Leap year means it will have 366 days. Okay, 366 days are equivalent to 52 weeks plus 2 days. 52 weeks plus 2 days. In a week, how many days are there? 7 days are there. So if you divide it, no, so it will come out to be 364 plus 2. I can write it down as 364 plus 2, and 364 could be written as 52 into 7. 52 into 7, that will be 364 only plus 2 days. Okay, so there will be 52 weeks and 2 days. So in 52 weeks, you will be having 52 Sundays. You will be having 52 Sundays as well. You will be having 52 Mondays as well. You will be having 52 Tuesdays as well, and so on. Right? And 52 Saturdays would also be there. Say yes or no. Now these 2 days, what these 2 days could be? These 2 days could be either Sunday or Monday, or Monday or Tuesday, or Tuesday or Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday. Is that it? No. Or it could be Saturday, Sunday. Say yes or no. These 2 days could be either Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. Is that clear to you or not? Right? Now what they are asking, it should have 53 Sundays. So out of those 7 cases, which are your desirable cases? Out of those 7 cases, your desirable cases are, you need to have 53 Sundays. Already you are having 52 Sunday. You need 1 more Sunday. That means either you need this case or you need this case. Right? Sunday, Monday, or Saturday, Sunday. So out of 7 cases, you have 2 desirable cases. So answer will be 2 by 7. Already you are having 52 Sundays. You need 1 more Sunday. So in those 2 days, what all days are possible? Either Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. You need 2 Sundays. That means out of those 7 cases, 2 cases are my desirable. You need 1 more Sunday. You need 1 more Sunday. That means out of those 7 cases, 2 of my cases are desirable. Here I get 1 Sunday. Here I get 1 more Sunday. That's it. Is that clear to you? Absolutely, sir. Second one. 53 Sundays and 53 Mondays. 53 Sundays and 53 Mondays. So already you are having 52 Monday and 52 Sunday, right? Already you are having 52 Monday and 52 Sunday. You need 53 Sundays, you need 53 Mondays. That means you need one more Sunday, you need one more Monday. One more Sunday and one more Monday you need. That means this is your desirable case, no? That it has to be Saturday and Monday. Saturday and Monday. Is that clear to you or not? It has to be Saturday and Monday. Right? It cannot be Monday, Tuesday. It cannot be Tuesday, Wednesday. It cannot be Wednesday, Thursday. It has to be Sunday, Monday. Is that clear to you? It has to be Sunday and Monday. So there is only one case out of 7. One desirable case out of 7. Third question. 53 Sundays or Mondays or 53 Mondays. That means if you have 53 Sunday, that will also be accepted. If you have 53 Monday, that will also be accepted. If you have 53 Sunday Monday, that will also be accepted. That means Sunday Monday I will accept. Here you are having 53 Sunday and 53 Monday. I will also accept Monday Tuesday. Why is that so? Why I am accepting Monday Tuesday as well? Because sir, here I will have 53. In this case I will have 53 Monday. In this case I will have 53 Sunday and 53 Monday. And in this case I will have 53 Sunday. Is that understandable to you or not? In this case I will have 53 Monday, in this case I will have 53 Sunday, and in this case I will have 53 Sunday and 53 Monday. That means there are total 3 cases out of 7. Or is written, no? Or. What is the meaning of or? Or means union, right? Union you need to take. What does that mean? That means only Sunday will also be accepted, only Monday will also be accepted, Sunday and Monday will also be accepted. So 53 only Monday, that will also be there, 53 only Sunday will also be there, and 53 only Sunday Monday will also be accepted. Right? So that means answer is 3 by 7. So that's the answer. So these are the answers that has been written. 3 by 7 is there, 1 by 7 is there, and 2 by 7 is there. So these are the answers that are written. Is that clear to you? So these kind of questions are very famous. How to solve these famous questions, that is clear to you now. Okay. So leap year you need to take. Leap year I will take. 52 weeks would be there. 2 days will be left. Now those 2 days could be either Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, or Saturday, Sunday. These are the total 7 possible cases. First case you need 53 Sundays. That means you need one more Sunday. So here you will get one Sunday. Here you will get one Sunday. 2 by 7. Next you need 53 Sundays and 53 Monday. That means Sunday, Monday only is the desirable case. 1 by 7. Next is 53 Sundays or 53 Mondays. Or means you will accept only 53 Sunday as well. You will only accept 53 only Monday as well, and you will accept 53 Sunday and Monday both. That means this case also you will accept, this also you will accept, and this also you will accept. 3 by 7 is the answer. Understandable? Well and good. Job done. Next we need to study about cards. So do you have idea about cards or not? Okay. We need to study about cards. So in cards there are 4 kind of suits. What is the word? 4 kind of suits. The name of first suit is spade, heart, diamond, club. Spade, heart, diamond, club. Okay. Spade, heart, diamond, club. In every suit there are 13 cards, or you call it 13 ranks. So in every suit there are 13 cards. Ace, this is known as ace, or this is known as ace. 2, 3, 4, 5, 6, 7, 8, 9, 10. This J is known as jack. What it is known as? Jack. This Q is known as queen. And this K is known as king. So let's not write it down. This has been written here. Okay. A is known as ace. J is known as jack. Q is known as queen. K is known as king. Understandable? What all are the face cards? These are the face cards. On these cards you can see that face has been made. Face has been made. No. So total 12 face cards are there. Total 12 face cards are there. Where it is written? 12 face cards are there. Total 12 face cards are there. How many number of aces are there? 4. How many number of 2s are there? 4. How many number of 3s are there? 4. How many number of 4s are there? 4. How many number of jack are there? 4. How many number of queen are there? 4. How many number of kings are there? 4. Okay. How many spades are there? 13. How many hearts are there? 13. How many diamonds are there? 13. How many clubs are there? 13. Is that understandable to you? Which are known as number cards? These are your number cards from 2 to 10. These are your number cards. Understandable? How many black cards are there? How many black cards? So this is also black and this is also black. So total 26 black cards are there. 26 black cards. Okay, and how many red cards are there? How many red cards are there? 26 red cards. So this has been written wrong actually. Heart is red, heart is red. So here this is black and this is black. So let's remove this. So 26 red cards, 26 black cards. Is that understandable to you? So this is black, this is also black, this is red, and this is also red. So 26 black cards, 26 red cards. Face cards you already know, black cards you already know, red card you already know, aces you already know, right? Anything else? Face card you already know now. Ace, everything, job done. That's it. Okay. And what is the highest rank? When we play cards, we think that this is the highest rank. No, ace is highest. We consider ace as highest, but actually, in probability, king is considered as highest. Although it will be mentioned in the problem. If they are asking about the highest rank card, if it is not mentioned, no, so by default you will take king as the highest rank card, not ace. People think that ace is the highest, but I will say king is the highest. In probability, we will take king as the highest. But when we play the cards, we take ace as the highest. But here king will be highest. Ace will be considered as 1. Okay, ace will be considered as 1. So ace will be actually lowest, not highest. So ace is considered as lowest, king is considered as highest. Understandable? Okay, so this is the order of rank is written. King, queen, j, 10, 9, 8, 7, 6, 5, 4, 3, 2, ace. Understandable? Let's solve the problems. It will become more clear to you. A card is drawn randomly from a well shuffled 52 cards. What is the probability that the drawn card is neither a heart nor a face card? Neither nor could be replaced as 1 minus either or. Right? Probability of neither a heart nor a face. It could be replaced as 1 minus probability of either heart or face. How will you read it? I told you either tea or coffee. That means you bring only tea, that is also fine. If you bring only coffee, that is also fine. If you bring both tea and coffee, that is also fine. Right? So how will you read it? 1 minus either you bring a heart or you bring a coffee. Sorry, or you bring a face card. That is fine for me. What does that mean? That means you need to take all the cards which is having heart or face. So how many hearts are there? How many hearts are there? Sir, how many hearts are there? 13 hearts are there. 13 hearts are there. Sir, how many hearts are there? 13 hearts are there. 13 hearts. 13 hearts plus 3 plus 3 plus 3. 13 plus 9. So these are your hearts and face cards. Did you understand this point? 13 plus 9. Total face cards are 12. Out of those 12, 3 are hearts only, no? So these are 12 plus these cards more. So 12 plus 3, 12 plus 10, it would be 22. So 20 cards are there which are either heart or face card. These are 13, 13 plus 3, 16, 16 plus 3. These are 13, 13 plus 3, 16, 16 plus 3, 19, 19 plus 3, 22. So total 22 cards are there which are either a heart or a face card. So 1 minus 22 by 52. 1 minus 22 by 52. So what will be the answer? 30 by 52. Or you can say 15 by 26. That's the answer. Okay. 15 by 26. Understandable? Very simple question. Next one. Listen to the explanation very carefully. Have patience and listen to the explanation very carefully. If you try to solve it on your own, you might be able to solve one question, two questions, but in the examination hall, you might be struggling in good level of problems. So have patience and listen to the explanation very carefully. You are having 52 cards, well shuffled 52 cards I am having. I need to find out the probability. So first of all, what I am doing, I am drawing 3 cards out of those 52. 3 cards I am drawing. So 1 card I will draw. And what is written? 3 cards you are drawing without replacement. So if I have drawn 1 card, then how many cards I will be left with? 51 card. Then I have drawn another card. How many cards I will be left with? 50 card. And after that, how many card I will be left with? Another one I will draw. 1 card drawn. 1 card drawn. And 1 card drawn. So I will be left with 49 cards which will not be used. Okay. Now what they are asking? They are asking the probability that drawn cards are king, queen, jack in the same order. First of all, you let me know how many kings are there. Sir, there are 4 kings, right? There are 4 kings. There are 4 kings. K, 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 K. There are 4 kings. How many queens are there? There are 4 queens. And how many jacks are there? There are 4 jacks. 4 and 4. 4 kings, 4 queens, and 4 jacks are there, right? First question, what they are saying? You need to draw the card in a manner that first has to be king, second has to be queen, and third has to be a jack. In that manner, you need to draw. So initially, I am having 52 cards. Out of those 52 cards, I am having 4 chances that I will get a king. So one card I have drawn. Since I have drawn one card, how many cards I am left with? 51. So I need to draw the cards in a manner that first card is king and second card is queen. Now I am left with 51 cards. Out of those 51 cards, how many of them are queen? So the first card that I draw, that came out to be king only. So how many queens are left? One of those cards are gone. But these are completely left. No, all 4 queens are left. All 4 queens are left. All 4 queens are left. Since I have drawn one more card, now I am left with 50 cards. So first has to be king and second has to be queen and third has to be jack. So I have drawn 2 cards now. First one was king. The second one was queen. How many jack are left? Sir, one card has been gone from queen as well and king as well. But sir, jack is left. 4 jacks are left. Complete 4 jacks are left. So answer would be 4 by 51. That would be the answer. Answer of first question. That would be 4 into 4 into 4 divided by 52 into 51 into 50. That would be the answer. Order is the same. First has to be king, second has to be queen, third has to be jack. So out of 52, you have 4 chances. Out of 51, you have 4 chances. Out of 50, you have 4 chances. And in between, there is a sense of and. First has to be king and second has to be queen and third has to be jack. And if there is a sense of and, I will multiply. Understandable? Next, what they are asking, find the probability that drawn cards are king, queen, jack in any order. King, queen, jack in any order. So second one, they are asking, it should be king, queen, jack in any order. That means first is king, second is queen, third is jack, or first is king, second is jack, third is queen, or first is queen, second is king, third is jack, or first is queen, second is jack, third is king, or first is jack, second is queen, third is king, or first is jack, second is king, third is queen. These total 6 cases are there. So how would you solve these kind of problems? First of all, let's find out the probability. You are having 52 cards. Out of them, one card has to be king. Then you are left with 51 cards. Out of them, one card has to be queen. Then you are left with 50 cards. Out of them, one card has to be jack. You draw a card. First card came out to be king. That means out of 52, you are having 4 chances. Then the drawn card is not placed back, right? Without replacement. So you are left with 51 cards now. Out of those 51 cards, you are having 4 jack. Now you are left with 50 cards. Out of those 50 cards, you are having 4 chances of queen. Similarly, first card you thought that it should be queen. So after 52 chances, you are having 4 chances. Multiply with, because there is a sense of and. First has to be queen and king and jack. So and means multiplication. Then now card is not placed back, so you are having 51 chances. Out of those 51 chances, 4 cards could be king. Now you are having 50 chances. Out of those 50 chances, 3 cards could be jack. In that manner, it will keep on going. The same probability here, the same probability here, and the same probability here. Whatever the probability you are writing down here, whatever the probability you are writing down here, and whatever the probability you are writing down here, the same probability you are getting. That means the answer is 4 into 52 into 4 into 50. 4 divided by 52 into 4 divided by 51 into 4 divided by 50, and that is multiplied 6 times. 1, 2, 3, 4, 5, 6. Multiply with 6 times. This is the answer. This could be written as 4 divided by 52 multiply with 4 divided by 51 multiply with 4 divided by 50 and 6 could be written as 3 factorial. Okay. So how would you think in the examination hall how to solve these kind of questions in the examination hall? How will you solve it? Look, this question is coming. If this question is coming, you will be directly able to know that there is only one case, sir. First has to be king, second has to be queen, and third has to be jack. King and queen and jack. So this is the only case. But if they are saying that in any order, then what you will do? You will make exam approach. You will make one case. What you will do? You will make one case. That, sir, I need to draw cards. I need to draw cards in a manner that should be king, queen, jack in any order. In any order. In any order. So you will make one case only. One case that you are taking the case that first has to be king, second has to be queen, third has to be jack. Find the probability of this case. That, sir, first has to be king, multiply with second has to be queen. 51 cards are left. Out of those 4 are queens. Then 50 cards are left. Out of those 4 are jack. Sir, this is the probability of one case. But sir, there could be here how many ways are there that you can change KQJ. Sir, the other way would be KJQ. Sir, other way could be QKJ. Other way could be QJK. Sir, other way could be JQK, and other way could be, sir, JKQ. So total 3 factorial ways are there. You are having 3 places here. Any of king, queen, J could come. Here 2 chances are there, and here 1 chances are there. So total 3 factorial chances are there. So I have find out the probability of only one case. I have find out the probability of only one case. So there could be 6 cases like that. So total it will be multiplied with 3 factorial. That would be the answer. Is that clear to you? Say yes or no. So this is the answer we have got. These are the answer that we have got. Now what really happened was, when I checked the option, the options were written somewhat like this. Okay, they have written the answer directly. So you can simply solve it now, right? 4 into 4 into 4, and you can simply solve it, you will get these answers. Okay. But now when I checked the option, no, they are written in this manner. 52C3, in that manner answers are written, sir. 4C1, in that manner answers are written. So how will I check? How will I get those answers? When I check the option, no, sir, answers are given in the terms of combination and permutation. So how will I check, sir? 4C1, how will I check it? This is how the answers are written. So how do I check? So the way of checking those is, your answer is 4 into 4 into 4 divided by 52 into 51 into 50. Do you know what is 4? 4 is nothing but 4C1. This is also nothing but 4C1. This is also nothing but 4C1. Divided by 52 into 51 into 50. How you can get it? Sir, I can get it by 52C3 multiply with 3 factorial. If your concept of PNC is fine, then you will be able to write down in this manner. 4 could be written as 4C1. Although a lot of people will solve in this manner, that 3 cards could be drawn. So 52C3. Then 1 card should be drawn from king, 1 card should be drawn from queen, 1 card should be drawn from jack. But sir, what about the explanation of 3 factorial? They will not have any explanation. They will say that, okay, there has to be king, queen, j, same order. That's why we are multiplying with 3 factorial. So here your intuitions are not clear, I know. That's why I am not even teaching you with the concept of a combination. We will not even apply the concept of combination. In the whole probability lecture, rarely we will apply this concept. But who knows answer are written in this way. So how will you solve it? If your concept of PNC are decent enough, or if you know the basics of factorial, that you would know that, sir, this is 4C1, this is also 4C1, this is also 4C1. This is 52C3. Now what is 52C3? I have told you a way. What is 52C3? So 52C3 means this is 3 here, no? So write down 52 in 3 ways, like 52 subtracted with 1, 51 and 50. So 52 into 51, 50. 3 times I need to write down, divided by 3 factorial. Divided by 3 factorial. Let's just say I need to write down 7C3. What will be 7C3? 7 into 6 into 5 divided by 3 factorial. 7C3, that means write down 7 in 3 ways. 7 into 6 into 5, 3 times, 1, 2, 3 divided by 3 factorial. That will be the answer of 7C3. Okay, so it will be equals to 35, because 6 3 factorial will become 35. So similarly, what will be 52C3? So 52C3 will be nothing but 52 into 51 into 50 divided by 3 factorial. Now this is 3 factorial. If you multiply with this, if you multiply this number with 3 factorial, or this 3 factorial goes here, then what you will be getting? 52C3 into 3 factorial will be 52 into 51 into 50. So 52 into 51 into 50. Yes, 52C3. into 3 factorial. What about this one? How will you write down this answer? So this answer would be written as, how this could be written? 4c1 into 4c1 into 4c1 divided by 52c3 into 3 factorial multiply with 3 factorial. So 3 factorial and 3 factorial will get cancelled out. So this is your answer here. Here this will be your answer. Okay. So both kind of answer could be mentioned in the examination hall. In the option, any kind of answer could be mentioned. This answer could also be mentioned. But again, we will not understand the intuition of this answer. No. In the examination, if we are asked to solve the problem, this is how we will solve the problem. King, queen, J. In the same order, then only one case is possible. In any of the order, then 6 cases are possible. I will find the probability of only one case, then multiply with 6. That's it. Is that clear to you or not? So this is how I will solve the problem in the examination hall, not in this way. Because here intuitions will not be clear no matter how much I explain. I will say from 52 you need to draw 3 cards, and from 4 kings you need to draw 1 card, from 4 queens you need to draw 1 card, from here you need to draw 1 card. Right? Understandable? But again intuitions are not clear. Then you will say that sir, order is not important, then multiply with 3 factorial. Here you will say sir, why we are not multiplying with 3 factorial? Things will become complex for you. Okay? So better, whatever the intuition that I have given, first make one case. King, queen, J. Here there is no importance of order, so I will make one case. I will find out its probability. Then I would know that there could be total this kind of 6 cases. So multiply this probability with 6. Here only one case is possible because they have given that order has to be king, queen, J. So first has to be king and queen and J. Is that clear to you or not? Is this process clear to you or not? Your very, very, very important concept. A lot of people will try to solve it with P and C and they will mess it up. Telling you. But we will go with the pure concept, pure understanding that this is how we are solving it. Okay, more questions we are going to solve, a lot of questions we are going to solve. Eventually your concept will be clear. Next question. 4 cards are drawn at random from a well shuffled 52 playing cards. Okay, find the probability that all 4 cards are drawn from the same suit. How many suits are there? How many suits are there? 4 kind of suits are there: spade, diamond, heart and club. These 4 suits are there. These are the 4 suits. These are the 4 suits. Look, they have written that 4 cards are drawn at random. Okay, 4 cards are drawn. Sir, here it is not written that you are replacing it back or you are not replacing it back. So you will understand that it is without replacement. By default, it is without replacement. Let's just say you are having 4 balls. Okay, let's just say you are having 5 balls. You are having 5 balls, and I am asking you select 2 balls from it. Select 2 balls. So what you will do, first you will select B1 and then you will select B2. That means first you will take B1, 4 balls are there, B1, B2, B3, B4, B5. First you will take B1 and then you will take B2. So once you have taken B1, after that are you placing your B1 back? No, you have taken B1 and then you are taking B2. 2 balls you are taking. That means you are taking the balls without replacement, no? So if they are saying that I am picking 4 cards out of 52, I am having 52 cards. C3, C4, C5, C6, total 52 cards are there. I need to take 4 cards. So first I will take C2, then I will take C2, C4, then I will take C5 and then I will take C6. So 4 cards I am taking. That means all 4 I am taking without replacement, no? So if nothing is mentioned, no, then it is by default without replacement. Because when you take 4 things, I am asking you, there are 100 toffees, there are 100 candies, and I am asking you that pick up 4 candies. So what you will do? You will pick up 1 candy. Will you place it back? No. You will pick up 1 candy, then another candy, then another candy, then another candy. 4 candies you will pick up. So you pick without replacement. So if they are saying 4 cards are drawn, then by default they are without replacement. Okay, they are by default without replacement. Understandable? So you are taking the cards without replacement. Understandable? Next, what they are asking, all 4 cards are drawn from the same suit. Let's just say I take an example that first question I am solving, no? All 4 cards has to be from the same suit. Let's just say first card is from spade. First card is from spade. The next card has to be from spade only. The next card also has to be from spade only. And the next card also has to be from spade only. Or let's just say first card is diamond. The next card also has to be diamond. Next card also has to be diamond. And next card also has to be diamond. Let's just say first card is heart. The next card also has to be heart. This also has to be heart. And this also has to be heart. Or let's just say first card is club, the next also has to be club, next also has to be club, and next also has to be club. These are your desirable cases. Apart from that, any desirable case is there? Absolutely not. So what is the probability that there are total 52 cards? First card you are drawing, it has to be a spade. So after 50 through 2, how many spades are there? 13. Now sir, one card I have taken out, that was a spade. Now how many of them are left? How many cards are left? Sir, 51 are left. Out of those 51, how many of them are spade? Sir, 12 of them are spade. Now how many cards are left? Sir, 50 cards are left. Out of those 50 cards, how many of them are spade? Because two cards that you have drawn, first one was spade, second was also spade. So two spades are gone. 11 spades are left. Now 41 are left. 49 are left. Out of them, how many of them are spade? Only 10 of them are spade. Because first was spade, second was spade, third was spade. So 3 are taken out, only 10 of them are spade. So 13 by 52, 12 by 51, 11 by 50, 10 by 49. Similar thing would happen with the diamond as well. That there are total 52 cards. Out of those 52 cards, 13 are diamond. Right? Now how many of them are left? 51 are left. One diamond is gone. How many diamonds are left? 12 diamonds are left. How many cards are left? 50 cards are left. After them, how many of them are diamond? 11 of them are diamond. Now how many of cards are left? 49 cards are left. 3 I have drawn, all 3 were diamond. How many diamonds are left? 10 diamonds are left. Similarly, the same probability here. Similarly, the same probability here. Right? So what do you understand? What is the answer? 3 by 52 into 12 by 51 into 11 by 50 into 10 by 49 multiply with 4. That's the answer. This is the answer. So again, let's write down the answer in a correct way, in a better way. So it is 13 into 12 into 11 into 10 divided by 52 into 51 into 50 into 49 into 4. If someone is intelligent, then he would know that it is nothing but 13C4 divided by 52C4 multiply with 4. This is the answer. And this kind of answer would be written in the examination. 13C4 divided by 52C4 multiply with 4. Although let's keep it because next question also we need to solve. But as of now, this is the answer. Did you understand this point? We will solve in this manner. We will not solve with the concept of a combination. Okay, because with the concept of combination, you will be solving one question, two question, but third question like this, you will be messing up. So that's why first question only I took in a way that your habit of solving the problem with the concept of combination, you will be dropping this habit. You will be solving the question with the pure concept like this. Drop the habit of solving the problem with the combination concept. You will solve by this pure concept that you take one case and then you think what all cases are there. Here also I took one case that spade, 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 spade. Then it could be diamond, 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 diamond. Then it could be heart, 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 heart. Or it could be club, 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 club. So now my question is that if there are 52 cards, you are drawing 4 cards, all 4 cards has to be spade. What is the probability of that? All 4 cards has to be spade. What is the probability? So initially, sir, I am having 52 cards. Out of them, 13 has to be spade. Multiply with, now one card is drawn. Now I am left with 51 cards. Out of those 51 cards, I am having 12 spades. Then I am left with 50 cards. Out of those 50 cards, I am having 11 spades. Now I am left with 49 cards. Out of those 49 cards, 10 are spade. The same thing will happen with diamond as well. Same with heart, same with club. So whatever the answer I got, multiply with 4. That's the answer. So 13C4 divided by 52C4 multiply with 4. That's the answer that we are getting. Understandable? Second question. No 2 cards are drawn from the same suit. What does that mean? That means 4 cards you need to draw. Do we have the page? Yes. Next question is no 2 cards from the same suit. No 2 cards from the same suit. From the same suit. What does that mean? That means all 4 cards should be from different suits. Say yes or no? All 4 cards should be from different suits. Is that understandable to you? No 2 cards from the same suit means all 4 cards should be different. That means if I draw the first one, it has to be, let's just say I draw the first one, it was spade. Then second one can be anything but not spade. First one was spade, then second one could be anything but not spade. That means first is spade, second one could be diamond. Now third one could be anything but not spade and diamond. It could be club. Now first one is spade, second is diamond, third is club, then first has to be heart only. So this is a desirable case. Now what is the way of adjusting these guys? How many ways are there? 4 factorial ways are there. What I mean to say is that first one could be spade only, then second one could be diamond, third could be heart, fourth could be club. Or first one is spade only, understandable? Second is club, diamond, heart. Or first one is spade only, club, heart, diamond. Is that clear to you? Understandable? Or first one is spade, then diamond, diamond I have taken, club, club I have taken. Now second is heart, third one is club, fourth one is diamond. First one is spade, second is heart, third one is diamond, fourth one is club. So total 6 cases are there where spade is at the first place. Spade being at the first place, total 6 cases are there where spade is at the first place, and then diamond, club, heart, they are getting changed. Diamond, heart, club, club, heart, club, diamond, heart, club, heart, diamond, heart, club, diamond, heart, diamond, club. So now spade is at the first place. Now what may happen is that diamond becomes at the first place, and then spade, club, heart. Diamond at the first place, spade, heart, club. In that manner, 6 cases more you will get here. One more, one more, one more, one more. 6. Now at the first place club will come. Spade, diamond, heart. Club, spade, heart, diamond. In that manner, more 6 cases. Right? And similarly, on the first place heart would come, then diamond, spade, heart. Sorry, diamond, spade, club. Heart, diamond, club, spade. In that manner, more cases, more 4 cases. So 6 into 6, 6 into 6 into 6, total 24 cases would be there. And it is very simple concept, no? It is very simple concept of a P and C. That spade, diamond, club, heart. How many combination you will be able to make from here? 4 places are there. So how many combination I will be able to make? 4 factorial, that's it. So what you need to do is that you need to take one case which is spade, diamond, club, heart. You need to take this case and you need to multiply the probability with 4 factorial. What does that mean? That means, sir, you are having a card, you are having a deck of 52 cards. Out of those 52 cards, you need to find out the probability such that first card is spade. Out of those 52, I am having 13 spades. Second card is diamond. Now I am not replacing it back. So how many cards are I am left with? 51 cards I am left with. How many diamonds would be there? Sir, first card was spade only. First card was spade. So spades are 12, but diamond are 13 only. Diamond are 13 only. Now how many cards I am left with? 2 cards I have drawn. That means I am left with 50 cards. Out of those 50 cards, 2 cards are gone. One card was spade, other card was diamond. How many clubs are left? Sir, 13 clubs are left. And sir, I am left with 49 cards now. So out of them, sir, 1 spade is gone, 1 diamond is gone, 1 club is gone. What is left? 1 heart is total 13 heart are left. Total 13 heart are left. Understandable? From 52, 13 spade were there. From 51, 13 diamond are there. From 50, 13 clubs are there. From 50, 13 hearts are there. Now this is one case. These kind of total 24 more cases would be there. There you go. This will be the answer. So this could be written as 13C1 multiply with 13C1 multiply with 13C1 multiply with 13C1 divided by 52C4. 52C4. Because what will be 52C4? So 52C4 would be nothing but 52 into 51 into 50 into 49 divided by 4 factorial. So 52 into 51 into 50 into 49 divided by 4 factorial, those 4 factorial goes upward. So it is nothing but 52C4. So what is the answer? Answer will be written in this way in the examination hall: 30C1 to the power 4 divided by 52C4. This is how the answer would be written. There you go. This is how the answers would be written. Is that understandable to you? But will you solve the concept? Will you solve the problem with the concept of a combination? No. I will solve with the pure concept. Take one case and then see what all possible cases are there. I have taken one case which was spade, 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 spade here. Then I know that total 4 kind of cases are there. Multiply with 4. Here I took one case which was first one spade, second one diamond, third one club, fourth one heart. Now you need to replace these guys. You need to make the combination of these guys. These guys will have total 24 combination. First could be spade, then club, then heart, then diamond. In that manner, total 24 cases would be there. All 24 cases I have written here. You should have the concept of PNC clear. The total 24 cases would be there. I will take one case. I will find out the probability of this case. What probability would be there? Sir, 52 cards, out of them 13 are spade. Sir, now I am left with 51 cards only. Out of them, how many of them are diamond? 13 are the diamond, because first one was spade only. So in that manner, I will write down multiply with 4 factorial. Now answer could be written in this way, and this is how I can make it. 13C1, 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 52C4. There you go. So this is how I will get the answer. Okay. I will never ever solve with the concept of a combination, because I will be messing up that question. One question I might be able to solve, two question I might be able to solve, but in the examination there is very high chance that you will mess up the question. But if you make the cases like that, there is no chance that you will mess up the question. You will surely get the correct answer. Say yes or no. Absolutely clear, sir. Let's try solving next question. Two cards are successively drawn without replacement from a well shuffled card of 52. If this word was not written, then also I would know that it is without replacement only. The probability that both cards are kings. Both cards are kings. Now, given that the first card is king, find the probability that second card is also a king. Okay. So first question, both cards are king. So first one has to be king, other one also has to be king. This is the only one case. So now, initially I am having 52 cards. Out of them, 4 will be king. Without replacement I am doing, no? Without replacement I am doing. Then now I will be left with 51 cards. Now I will be left with 51 cards. First one was king only. So now I will be left with 3 kings only. Right? First I got king. Once I have got king, that means I am left with 51 cards, and out of those 51, only 3 will be king. This will be the answer. Is that clear to you? Right? This is the answer. Now next question, what they are asking. So this was the probability of both cards are king. Both cards are kings. So first card is king, second card is also king. And how many ways are there? Sir, here adjusting KK. Adjusting K1, K2, how many ways would be there? Sir, 2 factorial, 2 ways would be there, because K1, K2 and K2, K1. But both are same, no? K1, K2 both are same, so divided by 2 factorial. So how many ways are there? Only one way is there. So here only one way is there, so you need to multiply with 1. So answer will be 4 by 52 into 3 by 51. Basically, someone would say that, sir, these kind of cases here, 24 cases are there. So similarly, here also there will be cases, no? So K1, K2 was there, then K1, K2 would be one way, K2, K1 would be one way. So total 2 ways are there. But K1, K2 are same. K1 equals to K2 here. That means there is only 2 divided by 2, only one case. I hope you know this concept. Like K, 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 H, 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 H. How many ways are there that I can place them? The total 7 values are there, so 7 factorial divided by 4H are same, 4 factorial divided by 3K are same, divided by 3 factorial. These will be the ways. Right? So similarly, here KK is there, so total ways will be 2 factorial divided by 2 factorial. So total 1 way would be there, so you multiply with 1 or you don't multiply with 1. So basically, first card has to be king, second card has to be king. So out of those 52, 4 chances are there. Now one king is gone, so I am left with the 51 cards. Out of them only 3 are king. So this is the answer. Understandable? Okay. And how it could be written? It could be written in this manner: 4C2 divided by 52C2. Because what will be 4C2? So 4C2 will be nothing but 4 into 3 divided by 2 factorial. And what will be 50C2? That will be 51 in 52 into 51 divided by 2 factorial. 2 factorial get cancelled out. It is 4 into 3 divided by 52 into 1. So this is how the answer would be written: 4C2 divided by 52C2. Someone would be saying that, sir, how I will be able to think? You will be having 4 options, no? You solve those 4 options, you will be able to see it. And it is not that tough to solve those 4 options. No, this is very straightforward. Very easily you will be able to solve all those 4 options. Right? So this might be mentioned in the options. So this is how you will be able to solve it. Next question. Given that first card is king, find the probability that second card is also a king. So what you need to find out? Second card is king. You need to find out the probability of second card is king, given that first card is also king. First card is also king. So this could be written in this way. In what way? Probability that second card is king. Intersection first card is king, right? First card is king, divided by probability of first card being king. First card is king. Say yes or no. Right? I am simply applying the formula. Which formula I am applying? P of A by B. P of A by B is nothing but P of A intersection B divided by P of B. So how this intersection could be taken as? It could be taken as AND. Right? So what is the probability you need to write down? You need to write down the probability such that first card is king and second card is king. Have we find out this probability? Find the probability that both of the cards are king. Right? So you need to find the probability such that first card is king and second card is king. What is the probability? So that probability is nothing but 4 by 52 multiplied with 3 by 51 divided by find the probability such that first card is king. This formula I have applied, which I will keep in a box. Now what you need to find out? You need to find out the probability such that first card is king. What is the probability that first card is king? You are having a 52 cards, you are having a deck of 52 cards. Out of them, what is the probability that you are drawing a card which is a king? What is the probability? You are having 4 kings, so answer will be 4 by 52. What you are finding? You are finding the probability such that second card is king and the first card is king. That means both cards has to be king. What is the probability such that both cards are king? What is the probability? That is, sir, 4 by 52 into 3 by 51. 4 by 52 into 3 by 51 divided by the probability such that first card is king. So when you draw the card, given that first card is king, so find the probability such that first card is king. What is the probability of getting a first card as king? That is 4 by 52. 4 by 52. This and this get cancelled out. What is the answer you are getting? 3 by 51. This is the answer that you are getting. What is the answer of second case? That is 3 by 51. Now let's understand a different way of solving the second problem. This answer we have got, that is 3 by 51, and here answer is 4 into 3 divided by 52 into 51. Whatever the answer is there, I don't care about the answer, but let's understand another way of understanding the second question. What they are saying, given that, do we have a page? No, we don't have a page. We need to add a page. What you need to find out? You need to find out what is given. Given that first card is king. First drawn card is king. First drawn card is king. First drawn card is king. Now you need to find out the probability that second card is also a king. Card is king. I give you an example, no? That let's just say I am tossing a coin 10 times. I am tossing a coin 10 times. Now on the initial 9 times, first I got tail, first I got head, then I got tail, then I got head, then I got head, then I got head, then I got tail, then I got head, then I got tail, then I got head. These are initial 9 tosses. Now on the 10th toss, what is the probability that I will get a head? What will be your answer? I am tossing the coin 10 times. I am tossing the coin 10 times. On the first 9 tosses, I got head, tail, head, 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 tail, head, tail, head. What is the probability that on the 10th toss, I will get a head? Sir, no matter whatever that has happened in that 9 cases, do you care about those 9 cases? In the 10th toss, so you are having sir 2 chances. Either you will get a head or you will get a tail. What you need to find out? You need to find out the probability of getting a head. What that answer would be? 1 by 2. So question is that you are tossing a coin 10 times. You are tossing a coin 10 times. In the initial 9 tosses, you got head, tail, head, 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 tail, head, tail, head. What is the probability such that you get a head on the 10th toss? Sir, whatever that has happened for the 9 times, I don't care. Virat Kohli has lost 9 tosses because we lose a lot of toss. No, same with me. When I play cricket, I never win the toss. Okay, if there is a coin which is having tail on both of the side, if I make a call, no, head will come. Okay, so I also never win the toss. So Virat Kohli has lost coin tosses in the last 9 matches. Now, if you ask Virat that how many chances are there that you will win the toss, he will say 50% chances are there, because either I can get a head or I can get a tail. So again 50% chances are there. Probability will say 50% chances are there, no matter whatever that has happened in the previous 9 tosses. Similar thing is there that first you have drawn a king. First you have drawn a king. From the 52 cards, you have drawn a king. You have drawn a king. The king has been drawn. King has been drawn. King has been drawn. Now how many cards are left? 51 cards are left. Now in those 51 cards, how many kings are there? 3 kings are there, and 53 minus 1, 48 other cards are there. 48 other cards are there and 3 kings are there. Now this condition is going into this case. What they are asking, that first you are having 52 cards, first card is drawn, that is king. Now you are having 51 cards. Now those 51 cards, from those 51 cards, what is the probability that you will get a king? So in those 51 cards, there are 3 kings out of those 51 cards. That will be the probability. That's it. I don't even need to apply any conditional probability condition or anything like that. Pure brain, pure mind I am using. That sir, first card is king. Now drawing the second card will depend on the first card. Whether the first card was king or queen, I don't care. I only need to see how many total cards I am having. So after drawing first card, I am having total 51 cards. Out of them, 3 are kings. That's it. So 3 by 51. Now if I ask you a question, find the probability given that first card drawn was ace, and the probability of drawing a king, given that first card drawn was ace. This question I am asking you. Find the probability that you are drawing a king given that first card was an ace. So what is the scenario? That I was having 52 cards. From those cards, sir, one ace I have drawn. So what I am left with? Sir, I am left with 51 cards now. Now out of those 51, what I need to do? I need to draw a king. So out of those 51, how many kings will be there? 4 kings will be there. So this will be the answer. There you go. That's it. You could have solved it in another way as well. How you could have solved it? Probability of drawing a king and an ace. Probability of drawing a king and an ace. That means probability of drawing a king and ace. So first I need to draw ace. So out of 52, I have 4 chances. And then I am left with 51 chances. And out of those, 4 are king. Divided by probability of drawing an ace. So out of 52, I have 4 chances. So 4 by 52 will get cancelled out. Answer will be 4 by 51 only. So this would be the other way of solving it. So both the ways are there. Here I need to apply that formula. Probability of A by B would be equal to probability of A intersection B divided by probability of B. That I am applying. That means probability of drawing ace and a king. First I am drawing a ace, 4 by 52, multiply with the king, because now ace is gone. Kings are left. Total here 4 kings are left. Again 4 kings are left. So now 4 by 51. So this is the probability, and divided by probability of drawing an ace, that will be 4 by 52. This and this getting cancelled out. Answer is 4 by 51. Here what I am doing, sir, 52 cards was there, ace is there. I am drawing first card as to be ace. How many cards I am left with? 51. Out of those 51, how many kings are there? 4. So what will be the answer? 4 by 51. That's it. This is the answer. Is that clear to you? All concepts are being clear. Here we are not even solving the problems. We are getting our concepts clear. Cleared as well. Say yes or no. Right? Concepts are also important here. Whatever the concepts that we are studying. Understandable? Let's solve more questions. More concepts will be clear. Try solving this one on your own. 2 natural numbers are selected at random from first 20 natural numbers. 20 natural numbers you are having. That means 1, 2, 3, 4 till 20. What is the probability that the sum of the selected number is odd? How will you get odd? I hope you know. This we have already studied in this lecture only. Even plus odd is 2 plus 3 odd. Odd plus even is 3 plus 2, that is also odd. Even plus even is even. 4 plus 4 is 8, that means it is even only. And odd plus odd is that is also even. 3 plus 5 is 8. Right? You can take the example 3 plus 5 8, 4 plus 2 6, 3 plus 6 9, and 6 plus 3 9. So what did you understand? Just 1 second. कौन कॉल कर रहा है भाई? Yeah. So what I was saying, even plus odd plus even, these are our desirable cases, right? Because I need the sum to be odd. So what is our desirable cases? Even odd or odd even. That means first number could be even, second number could be odd, or first number could be odd, second number could be even. This is our desirable case. So I will take one case, I will take only one case. I will take which case? That first number is even, second number is odd. This case I will take, and then what I will do? I will multiply the probability with 2. What I mean to say is that I need to select 2 numbers from 20 natural number. And if I am selecting it, I will select it without replacement. Basically, I ask you that select 2 numbers from 20. You will say, sir, I am selecting 2 and 3. That means you are selecting without replacement. No, 2 you have taken, then 3 you will take. So 2 and 3, 2 numbers you have selected. So without replacement, right? So from 1 to 20, how many odd numbers you are having? From 1 to 20, how many odd numbers you are having? Sir, in 1 to 20, I have 10 odd numbers, and 10 odd numbers are there, and 10 even numbers are there. Say yes or no? From 1 to 20, 10 odd numbers are there, 10 even numbers are there, right? So here, what is my question now? From 20 numbers, you need to select a number such that the number is even. From 20 numbers, you need to select a number such that the number is even. How many chances are there? 10 chances are there. And now since you have selected one number is gone. So how many numbers you are left with? You are left with 19 numbers. So out of those 19 number, you need to select a number such that the number is odd. So first number was even. That means from this one number you have selected, so now you are left with 9 even and 10 odd numbers. So out of 19, you are having 10 odd numbers. So this is the probability such that first number is even and second number is odd. You have find out the probability such that first number is even and second number is odd. What is the probability that first number is even? First number is even, so probability will be 10 by 20. Total 20 cases are there, total 20 numbers are there. Out of those 20 numbers, 10 are even. Now sir, one number I have selected, that was even. So how many numbers I am left with? I am left with total 19 numbers. And sir, how many of them are odd? So the number which was selected, that was even. So 10 odd numbers are left. So 10 by 19. So this you have find out. First number is even and second number is odd. Or it might be possible that first number is odd, second number is even. So what will be the probability of this? Sir, there are total 20 numbers. Out of those 20, 10 are odd. Now sir, since I have selected one number, I am left with only 19 numbers. I am left with only 19 numbers. Out of those 90 numbers, sir, one number that was selected was odd only. So out of those 90 numbers, how many of them are even? Sir, 10 of them are even. So 10 of them are even. So this will be the answer. So what is the answer? 10 by 20 into 10 by 19 into 2. Right? So it is coming out to be 10 by 19. This is the answer. That's the answer. Say yes or no. Understandable? So this is the solution of first question. What could be the solution of second question? The selected number has to be even. That means first number has to be even and second number has to be even, or first number has to be odd and second number has to be odd. So now you are having 20 numbers. Out of them you need to select 10, right? Out of 20, 10 are desirable cases. Now you are left with only 19 numbers. Here what you will write down? 9 or 10? I will write down 9 only. Why is that so? Because I have selected one number which was already even. So now how many even numbers are left? Only 9 even numbers are left, no? Say yes or no. Initially I was having total 20 numbers. Out of those 20 numbers, I am having 10 even numbers. Now one number is selected, that is even only. So now I am left with 19 numbers. Out of those 19, only 9 are even. That's why 10 by 20 into 9 by 19. Now I am left with, now I am having total 20 numbers. Out of them 10 are odd. Now I am left with 19 numbers. How many of them are odd? The number which I previously selected, that was odd only. So now I am left with only 9 odd numbers. Right? So what is the answer? 10 by 20 into 9 by 19 into 2. So what is the answer you will get? 9 by 19. That's it. This is the answer. This is the answer that you will be getting. And it is pretty obvious as well, because you are getting 10 by 19 as the sum is odd. So how many will be even? That will be 1 minus 10 by 19. So answer will be 9 by 19 only. Because sum would be either even or odd. If you do 1 plus 2, that would be, and one more thing, that it should be two different natural numbers. No, you are selecting two different natural numbers. Two different natural numbers. By default, you need to take there has to be different natural number, because if you take 1, let's just say I ask you to select two numbers from it. You say, sir, I will select 1 and 1. So 1 plus 1 will be 2. I will select 2 and 3. That will be 2 plus 3, 5. So there will be a lot of ways, no? So that we are not taking. Okay, we are taking different numbers. So if you are selecting 1, you cannot select 1 now. You will have to select some other number. So different numbers are there. Two different natural numbers you are selecting. Okay, two different natural numbers. So in the first case, you first have to take either, then odd, or first you take odd, then you take even. So this probability we have find out. And then in the second case, you take first even, second also even, first odd, second also odd. Understandable? So 9 by 19, 10 by 19. Understandable? Let's solve the next question. But I need to take a call. I will take that call and then we will solve this question. You try solving this question on your own. You should be able to tell the answer. What is the answer? Answer is half. Because we have already seen this explanation, no? 3 fair coin tosses are tossed simultaneously. Given that first 2 coins are showing head, find the probability that third coin toss will also, the third coin shows the tail. Although we will solve in a different way, complete we will solve, but just by looking at the question, can you tell the answer? Sir, no matter whatever that has appeared on the first 2 tosses, I don't care. Here, what is the probability of appearing a tail? That will be, sir, 1 by 2. Answer will be 1 by 2, right? So that we will see, but after a break. Okay, I need to take a break. I need to take a call. Then I will come back. We will solve this question. You try solving this question as well. Try solving this question on your own. Which question? This question you try solving on your own. Very simple, very straightforward, not a difficult question. You try solving this one, then you try solving this one as well, then you try solving this one as well. Okay, these 4 questions you try to solve. Let me take a break and then I will come back. Okay. Yeah, welcome back. So next question we need to solve. 3 fair coin tosses are 3 fair coins are tossed simultaneously. Given that first 2 shows head, then find the probability that the third one shows the tail. Like basically, if you toss 3 coins, then what all are the possible outcomes? So the possible outcomes would be whole head, head, tail, head, 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 tail, right? And head, tail, tail, or tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. These are the possible outcomes. These are total 8 possible outcomes, right? Now what they are asking the probability that find the probability that third coin toss shows tail. Third shows tail. Given that first 2 shows head. First 2 show head. This is what we are supposed to find out. What I can do, I know that this could be written as third show head, sorry, third show tail, intersection first 2 show head, right? Divided by first 2 show head. Probability of first 2 show head, right? What we are doing, we are simply applying the concept of conditional probability. Probability of A by B is probability of A intersection B divided by probability of B. This is what we are doing. Intersection could be written as N. So what you are supposed to find out? You are supposed to find out the probability is such that third shows tail, third coin toss will show tail, and first 2 will show head. That means your chances are first should show head and third should show tail. First 2 should show head and third should show tail. That means only one chance is there, no, out of 8. Divided by first 2 shows head. First 2 shows head. First 2 showing head. First 2 showing head. That's it. 2 chances are there out of 8. Answer is 1 by 2. That's the answer. Did you understand this point or not? Did you understand this answer or not? This was method 1. This was your method 1. We will see the method 2 as well. But method 1, did you understand or not? third coin toss should show tail divided by first two coin tosses should show head. So this could be written as first two showing head and third showing tail divided by first two showing head. So first, that means this is saying that two head and one tail. First two showing head and then one tail. What condition is there? Head, head, tail. Only head, head, tail. Only this one condition is there. One condition out of 8 divided by first two showing head. Third could be anything. It could be head or it could be tail. But first two should be head. It could be head here. It could be tail here. So answer is 2 by 8. Answer is 1 by 2. What is the method 2? Method 2 is showing that method 2 would be given that first two coin tosses are heads. Given that first two are head. Now what is the probability that third is tail? So first two are head, I don't care about it. They are fixed event. No, first two is head, it is fixed. Second is also head, that is fixed. I need to get here two possibility. Either it could be head or it could be tail. It could be either tail or it could be head. So here there are total two possible chances. Out of them desirable is that I should get a tail. So out of them desirable is 1. Answer is 1 by 2. Let me ask you another question. I am asking you another question that I am tossing 4 coins. This time I am tossing 4 coins. Initial 2 is showing head. First 2 are showing head. What is the probability that I will get exactly one tail on the next 2 coin tosses? I am tossing 4 coins. I am tossing 4 coins. Okay. First 2 showing are head. They are showing head. Find the probability such that I get exactly one tail in the next 2 tosses. So in the next 2 tosses, how many chances are there? Sir, 4 chances are there. Either you can get head head, or you can get head tail, or you can get tail head, or you can get tail tail. I need the chances where we are showing exactly one tail. In this chance you get exactly one tail. In this chance you get exactly one tail. So how many chances are there? 2 by 4. Answer would be 1 by 2. If the question was it shows at least one tail, at least one tail, at least one tail, that means one tail will also be accepted and 2 tails will also be accepted. So answer would have been 3 by 4. Is that understandable to you? So these kind of questions we will see next, but I hope it is understandable. This is how we will solve the problems now. Next question, let's take 10 coin tosses you are taking, right? 10 coin tosses you are taking. They are saying that first one is head, second one is head, third one is tail, fourth one is head, fifth one is head. These are the 5 coin tosses. Now in the next 5, first of all you let me know how many total chances are there. Sir, here you could either get head or you can get tail. Here you can either get head or you can get tail. Here you can either get head or you can get tail. Here either you can get head or you can get a tail. Either you can get head or you can tail or you can get a tail. Right? Head tail, head tail, head tail, head tail, head tail. 2 chances are there. So total 2 to the power 5. That means total 32 chances are there. So total possible outcomes are 32. Total possible outcomes are 32. Out of them, how many of them are desirable? What they are saying, in these 5 coin tosses, you need to have exactly 3 head and exactly 2 tail. That means you need to have exactly 3 head and exactly 2 tail. This is what they are saying. But is that the only condition? Is it necessary that sir first 3 should show head, then it should show tail? No. It might be possible that it could be like head, tail, head, head, tail. Or it could be like head, head, tail, head, tail. So you need to find out that 5 total possible chances are there, that basically on 5 coin tosses you need 3 head and 2 tail. Now you need to arrange them. So how many number of ways are there to arrange them? So total 5 guys are there. So number of ways would be 5 factorial. But 5 factorial would have been the answer if they were different. But since they are 3 head are same and 2 tail are same. 3 head are same and 2 tail are same. So I will have to divide them. So 5 factorial divided by 3 factorial divided by 2 factorial, that would be nothing but 10. So total 10 ways are there. Answer would be 5 by 16. This would be the answer. This is the answer. Did you understand this concept or not? Initial 5 are fixed, I don't care about it. Next 5 I need to take care about. Next 5 I need to take care about. Okay. So in the next 5, what they are saying? In the next 5, sir, total possible outcomes are 32. Either it could be all head, or it could be all tail, or it could be head, 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 tail, head, 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 tail, tail, head, tail, head. In that manner, 32 chances would be there. Why 32? Because here head tail, here head tail, here head tail, here head tail, here head tail. So total 32 chances would be there. Total 32 chances would be there. Total 32 chances would be there. Understandable? Now out of those 32, what is my desirable? That sir, there should be 3 head and 2 tail. 3 head and 2 tail. But this is not fixed. Initially there could be head, then there could be tail, then there could be head, head, tail. Or there could be initially 2 head, then tail, then head, then tail. This could be the way. Right? So there are 5 guys. You need to arrange 5 guys. Out of them, 3 are same and 2 are same. So 5 factorial divided by 3 factorial divided by 2 factorial. So total 10 ways are there to arrange these guys. How many ways are there to arrange these guys? So total 10 ways are there. I hope you know this concept of PNC, straightforward concept, that how will you arrange these guys. I told you always find out one condition and then you find out how many ways are there. So how many ways are there? 5 factorial divided by 3 factorial multiply with 2 factorial. So total 10 ways are there. Understandable? So answer would be 10 by 32 or 5 by 16. So this is the answer, which is 5 by 16. Understandable? So this is how we need to solve the question. Next one. 10 coin tosses. Okay. 10 coins are tossed simultaneously. Find the probability that among the first 4 coins, at least 2 will show head. What you need to care about? You need to care about only first 4 coin tosses. After that, whatever that you get, do you need to care about it? Don't care. What there? Here you either you get head or you get tail. You don't even care about it. You only need to care about first four coin tosses. First 4 coin tosses. Only first 4 coin tosses. So here either you get head or you get tail. 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 So total 16 possible chances are there. Total 16 possible chances are there. So total 16 possible chances are there. Right? Out of those 16, what is the scenario? That at least 2 should show head. At least 2. That means 2 heads will also be accepted. 3 heads will also be accepted. And 4 heads will also be accepted. If there are 2 heads, that means there will be 2 tails. If there are 3 heads, then there will be 1 tail. 1 tail. If there are 3 heads, then there will be 1 tail. And if there are 4 heads, that means there will be 0 tail. That means you can take 2 head, 2 tail, or there will be 3 head, 1 tail, or there will be all 4 head. So how many ways are there to arrange head, head, tail, tail? So total 4 guys are there, so number of ways will be 4 factorial. Divided by 2 factorial, divided by 2 factorial. Divided by 2 factorial, divided by 2 factorial, because these 2 guys are same. How many ways will be there to arrange these guys? So total 4 ways would be, total 4 factorial ways would be there. But sir, 4 factorial would have been there if they were different, but they are same. So 4 factorial divided by 3 factorial. And how many ways would be there? Sir, total 4 factorial would have been the ways. But sir, 4 factorial would have been the ways if all 4 were different. But now sir, all 4 are same. That's why divided by 4 factorial. So how many ways are there? 4 factorial divided by 2 factorial, that will become 6. This will become 4. And this will become 1. Right? So answer is 11 by 16. That would be the answer. 11 by 16 is the answer. Answer is 11 by 16. Did you understand this point or not? I hope you are understanding it. Very good question. These kind of questions are considered very good questions, but very easily we are able to understand. That only 4 coin tosses I need to care about. In the first 4 coin tosses, what do I know? In the first 4 coin tosses, sir, I know one thing, that I will have total 16 chances. Total different 16 chances would be there. What all are those 16 chances? Can you write down? Yes, sir. 8 times head. 8 times head, 8 times tail. This I told you, right? 8 times head, 8 times tail. Then 4 times head, 4 times tail. Then 4 times head, 4 times tail. Right? 1 time head, sorry, 2 times head, 2 times tail. 2 times head, 2 times tail. In that manner, then head, tail, head, tail, head, tail. Total 16 chances would be there. Sorry, total, yeah, 16 chances would be there. 8, total 16 chances would be there. Out of them, what do I need? At least 2 head I need. That means 2 head or 2 head and 2 tails, or 3 head and 1 tail, or 4 heads. So these are the chances that you get 2 head, 2 tail. But this is not the only condition. You can arrange them as well. So what is the total way of arranging? Sir, total way of arranging is 4 factorial. But if they were different, but sir, 2 guys are same here. Divided by 2 factorial, divided by 2 factorial. Sir, here total ways would have been 4 factorial, but sir, 3 guys are same, so divided by 3 factorial. Here, 1 way. So these are your total cases. Had, tell, or had, tell, or had. If there is a sense of or, that means there will be addition. There will be addition. That means 6 plus 4 plus 1. Total 11 ways are there out of 16. 11 by 16 is the answer. Understandable? Let's go to the next one. 4 cards are drawn with replacement. From a well shuffled 52 pack of cards. Find the probability that among these 4 cards drawn, 1 card is king, 1 card is queen, 1 card is jack, and 1 card is ace. Card may appear in any order. What they are asking? King, queen, jack, ace. With the replacement. So initially, this is one condition. But how many these conditions would be there? Total 24 conditions would be there. Why is that so? King, queen, jack, ace. King, queen, ace, jack. King, jack, queen, ace. In that manner, total 24 cases would be there. What you will do, you will take one case, you will find out its probability, then multiply with 4 factorial. So I am taking the case that first one is king, second one is queen, third one is jack, fourth one is ace. This is the condition that I am taking. So find the probability such that initially I am having 52 cards, out of them 4 will be king. Multiply with the replacement, that means again I am having 52 cards, out of them 4 will be queen. Now replacement means again I am having 52 cards, because I took a card, I saw that it is queen, I put it back. Now again I am having 52 cards, out of those 52, 4 are jack. Now again I am having 52 cards, out of those 52, 4 are ace. Multiply with 4 factorial, there you go, this is the answer. This is the answer. 4 by 52, 4 by 52, 4 by 52, 4 by 52, multiply with 4 factorial. Understandable? This is the answer. Did you understand this point? King, queen, jack, ace, one case I have taken. There would be total 24 cases like that. So multiply with 24. 4 factorial means 24 only. There would be total 24 cases like that. Why is that so? Because sir, here any of these cards may appear, any of these cards may appear, any of the card may appear, any of the card may appear. So 4 factorial cases would be there, 24 cases would be there. Multiply with 24. Now with replacement it is done. So from 52, 4 kings are there. Again I am having 52 cards, out of them 4 are queen. Again 52, 4 of them are jack. Again 52, 4 of them are ace. There you go. This is the answer. Understandable? Simple question, straightforward. If your concepts are clear, then they are simple. Otherwise they will become difficult. Next question. In a box there are 3 red balls, 4 black balls, and 6 blue balls. What is the scenario? 3 red, 4 black, and 6 blue. 4 balls are drawn at random, one after another, without replacement. Find the probability that selected set contains exactly 2 red, 1 black, and 1 blue. 2 red you need, 1 black you need, 2 red you need, 1 black you need, and 1 blue you need. So I will take one case. This case I will take red, black, blue. Find the probability such that you are having total how many balls? 6. Total 13 balls are there. So initially you are having total 13 balls. Out of them 3 are red. So first one was red only. So now I am left with 12 balls. And how many of them are red? 2 of them are red. Now I am left with 11 balls. How many of them are black? 4 of them are black. Now I am left with 10 balls. How many of them are blue? 6 of them are blue. But is this the answer? No. Why is that so? Because I need to arrange them as well. No. Because this case will not be there, like red, black, blue. This is not the only case. The case could be red, blue, black as well, right? Or it could be red, blue, red, black as well. Or it could be red, blue, black, red as well. So how many total ways would be there? Sir, I need to arrange these 4 guys, so total ways would have been 4 factorial. This would have been the answer if they were different. But sir, 2 guys are same, so divided by 2 factorial. So 4 factorial divided by 2 factorial, what answer you will be getting? 4 into 3. That means 12. So total 12 ways would be there. So multiply with 12. There you go. This is the answer. This is the answer. Is that clear to you? We can solve it further. If I solve it further, then 12 and 12 is getting cancelled out. Let's not cancel it out here. 12 and 12 is getting cancelled out. 13, 11 will not cancel out. So 2 here you get 5. 12, 12 getting cancelled out. 5 I will get, so divided by 15 and then 12. ये क्या हो रहा है भाई? This will become 5, right? 55 into 13. What is 55 into 13? 55 into 13. 715. So downward I am getting 715 actually. I forgot this 13. And then 2 is getting cancelled out. 12 is also getting cancelled out. So this will become 72. So 72 by 715. That will be the answer. This will be the answer. So always I have given you one way that you take one case and then you find out what will be the total cases. So total 12 cases would be there. Total this kind of 12 cases would be there. How I got those 12 cases? Sir, by using the basic concept of PNC. What I will do, sir, first I will find out one case that two of them should be red and one of them should be black, one of them should be blue. So red, red, black, blue. This box I was having total 13 balls were there. Initially 13 balls were there. Out of them 3 were red. One red is taken out. So I'm left with 12 balls. 2 red balls are there. 2 by 12. Now I'm left with 11 balls. Out of them 4 are black. Black is taken out. So 2 red are taken out. 1 black is taken out. I'm left with 6 blue ball, 3 black ball and 1 red ball. So out of those 10 balls, 6 of them are blue. So this is the condition. So this condition I have taken only for one cases. This kind of 12 cases will be there. So multiply with 12. Answer is 72 by 715. 72 by 715. So with the technique that I have told you, if you solve the problem with that technique, you will never struggle. Otherwise, you keep on applying the concept of combination. That sir, from 13 I need to get 4. Then from 3 I need to get 2. Then from 4 I need to get 1. Then from 6 I need to get 1. Right? Is the answer correct? No, answer is not correct. Right? Then something you will think, okay sir, now I need to arrange them as well, so multiply with 4 factorial. So all these things will not work. In the examination, as of now it feels cool that sir, yes, I am able to solve the problem, but in the examination you will either forget this step, surely you will forget this step, 4 factorial multiply with 2 factorial. You will solve only this much and this option will be mentioned in the examination. Okay, surely it will be mentioned. Is it correct? 13C4 divided by 4 factorial. No, this is not correct. Divided by 4 factorial, but divided by 2 factorial also. So it is actually very complex. Using the concept of combination, solving the problems are very complex. You will forget something. So forget about combination. No, we will study permutation combination in the PNC. That is the concept of PNC. Keep it there. Here simple thing is there. Take one cases, get to know how many total cases are there. One cases, total 12 cases are there. So what I do, I find out the probability of one case, multiply with 12, job done. That's it. Okay. So find out the probability of one case, that red, red, black, blue. So one probability I find out now. I know that there could be these kind of how many cases? There could be these kind of 12 cases. So multiply with 12, job done. Understandable? Let's go to the next one. 4% can solve a problem correctly with the probabilities 1 by 2, 1 by 3, 1 by 4, 1 by 8. I hope you are able to see it. 1 by 2, 1 by 3, 1 by 4, 1 by 8. Okay. 4 persons are there. A, B, C, D. A is solving the problem correctly with 1 by 2. He is solving with 1 by 3. He is solving with the probability 1 by 4 and he is solving with the probability 1 by 8. Respectively, assuming that all of them attempt the problem independently. They are attempting the problem independently. Then find out the problem, find out the probability that problem is solved, or find out the probability that at least one of them is able to solve the problem. So first of all, you let me know, both of the questions are same or different. Question 1 and question 2 are same or different. Let's just say you are 4 guys. Okay, you are 4 guys, A, B, C, D. Now to you 4 guys, I am giving one question. I am giving you one question. You guys need to solve this question. Okay. Let's just say if A is able to solve the problem. If A is able to solve the question. If A is able to solve the question, then problem is solved. Yes. Let's just say if B is able to solve the problem, then problem is solved. Yes. If only C is able to solve the problem, then problem is solved. Yes. If only D is able to solve the problem, then problem is solved. Yes. If AB are able to solve the problem, then also problem is solved. If BC are able to solve the problem, then also problem is solved. If CD are able to solve the problem, then also problem is solved. If A, B, C are able to solve the problem, then also problem is solved. If B, C, D are able to solve the problem, then also problem is solved. If A, C, D are able to solve the problem, then also problem is solved. And if A, B, C, D are able to solve the problem, then also problem is solved. That means when the problem will be solved, when the problem will be solved, problem will be solved, problem will be solved if at least one of the four guys is able to solve the problem. Like out of those four guys, one guy, if one guy can solve the problem, no, is able to solve the problem, then the problem will be solved. That means both questions are same. Question 1 and question 2 both are same. The problem will be solved if one of the guy is able to solve the problem. If one of the guy is smart enough, no, at least one of the guy. If one guy is able to solve the problem, then also problem is solved. If two guys are able to solve the problem, then also problem is solved. If three guys are able to solve the problem, then also problem is solved. If four guys are able to solve the problem, then also problem will be solved. When the problem will not be solved, there are four guys A, B, C, D. I am giving you one question. When this question will not be solved? If A is not able to solve the problem, if B is also not able to solve the problem, if C is also not able to solve the problem, and D is also not able to solve the problem. What does that mean? That means probability of solving the problem, probability of solving the problem is equals to probability of at least one of them solving the problem, right? If only one guy is able to solve the problem, then also the question would be solved. At least one of them solving the problem, at least one of the guys solving the problem, and that would be equals to 1 minus none of the guy solving the problem, none of the guy solving the problem. Do you understand this point or not? Did you understand this point or not? The problem is being solved, that is equivalent to at least one of the guys solving the problem, and that is equivalent to 1 minus none of the guys solving the problem. If none of them is able to solve the problem, then problem will not be able to solve. So 1 minus none of the guys is able to solve the problem. That means probability such that A is also not able to solve the problem and B is also not able to solve the problem. Basically, you need to write down in this way that A is also not able to solve the problem and B is also not able to solve the problem and C is also not able to solve the problem and D is also not able to solve the problem, but they are independent. They are solving the problems independently. Since they are independent, then this could be written as 1 minus A is also not able to solve the problem and B is also not able to solve the problem and C is also not able to solve the problem and D is also not able to solve the problem. So this will be the answer. Answer will come out to be 1 minus, what will be P of A bar? That will be 1 minus 1 by 2. That will be 1 by 2. What will be P of B bar? That will be 1 minus 1 by 3. That will be 2 by 3. This will become 3 by 4. And this would be 7 by 8. 2 get cancelled out. 3, 3. 7 by 28. Answer will be 7 by 32. So, okay. This will be 7 by 32. 7 by 32. So, 1 minus 7 by 32. What that would be? 32 minus 7. So, answer would be 25 by 32. Answer would be 25 by 32. That will be the answer. This will be the answer. This will be the answer. Answer is 25 by 32. This will be the answer. So, both are the same questions only. Both are same problem, same questions. Both are same question. So, problem is solved or one of them solving the problem are same. But sir, one of them solving the problem is a difficult task because I will have to think that A is able to solve the problem, but B, C, D are not able to solve the problem. Or B is able to solve the problem, but A, C, D are not able to solve the problem. Or C is able to solve the problem, but A, B, D are not able to solve the problem. Or D is able to solve the problem, but A, B, C are not able to solve the problem. Or A, B is able to solve, C, D is not able to solve. Or B, C is able to solve, A, D is not able to solve. Or C, D is able to solve, A, B is not able to solve. Or A, D is able to solve, but B, C is not able to solve. These cases plus A, B, C is able to solve, but D is not able to solve. B, C, D is able to solve, but A is not able to solve. A, B, D is able to solve, but C is not able to solve. Right? Plus A, B, C, D is able to solve the problem. So these many cases I will have to take. Right? but what they are asking, at least one of them is able to solve. That means 1 minus none of them will be able to solve. At least one of them would be equals to 1 minus none of them. At least one of this I have already written as well. At least one of is equivalent to, probability of at least one of is equivalent to 1 minus none of, right? So I will find out the probability that none of them are able to solve the problem. That means A can solve the problem with the probability 1 by 2, so he will not be able to solve the problem with the probability 1 by 2. He is able to solve the problem with probability of 1 by 3, then he will not be able to solve the problem with the probability of 2 by 3. He is able to solve the problem with the probability of 1 by 4, then he will not be able to solve the problem with the probability of 3 by 4. If he is able to solve the problem with the probability of 1 by 8, then he will not be able to solve the problem with the probability of 7 by 8. So total out of 32, there are 25 chances that they will be able to solve the problem. Say yes or no. Understandable? Right? Okay, let's go to the next one. P of A is given, P of B is given. You need to find out the maximum and minimum possible values of PA intersection B and PA union B. Very good question. Very good question. From the next lecture onwards, we will solve the problems from here. Okay. Till this point, these many questions are okay, but more questions I have written. This is the question we need to solve. This is the question we need to solve. Then this question we need to solve. A lot of questions are there. Okay. Questions and questions are also there. In the next lecture as well, we will solve questions and questions only. Concepts are already completed. Okay. Concepts are already completed. We need to solve the problems, but it's not that, sir, why we need to solve the problem. Concepts are completed. No. In the problems as well, you will understand a lot of new concepts. So yes, problem you need to solve. So this question we will solve in the next lecture. What you need to find out? P of A is given, P of B is given. You need to find out the maximum and minimum possible value of a PA intersection B, P union B. Okay. So you try doing it on your own. Make the Venn diagram and think about it. Understandable? So let's meet in the next lecture. Thank you very much.